Hey everyone, I know I'm a bit late again. I seem to not getting up early enough. Right, let me just get myself sorted out here. Hold on. I've done my chat window in here yet. So get that added. Wish it remembered the last one I used. It'd be a bit easier. Now we'll get the window the right size. Alright. Something right, isn't it? Okay. Right, is this camera right? Something right, isn't it? So here we got here. David, Dave, Sheridan, Fred, Christian, coffees. No. Coffees, morning coffees on the weekend are my responsibility. I made this. I'm assuming, of course, I've got audio and stuff. I think you would have told me by now. Right. Let's try and shuffle things around a bit better. My window's a bit of a mess. Yeah, alright. Slarty Bart fast. Alright. It's morning here. It's 8 AM. Wait, my words of wisdom. Wisdom. Hang on us. Move a cough over here. Still trying to wake up. Right, what are we going to work on? Hey Peter, how's it going? So I'm thinking about, hey Johnny. Hey sweetie. So my plan today, I've got a couple of potential things there to do, is mailbag. I want to potentially do a live mailbag. I've got one sitting here, well, a behind the scenes mailbag, you know. Only just got to sit on my desk already. I was going to record it yesterday, but I didn't get the chance. Alexander. So we could do a behind the scenes mailbag, you know, it's like a live one. Let's just change screens here, and then we've got something we can work on, which is titled in the live description, I think, actually. Yeah, what I'm looking for, what's not it? I want that one. Wow, I'm definitely with it today. Okay. Doesn't bode well for electronics equipment if I can't even get the right screen right. Okay. So you can see I've got some stuff there in the mailbag bench. Got a few things. One slightly squashed package. Pink LEDs. It's the wrong stream, Christian. There's no pink LEDs here. Completely wrong place. I think you're lost, Christian. There's pink LEDs here. Hey, Ian. Yeah. Anyway. If I can string a sentence together, it'd be great. I think I need to drink some more coffee. Hey, Johnny, you found one of the perks. I think you can do that for one live each live stream. You can do one of them. I think something like that. There's some kind of thing there. I'm not sure. Oh, Mike, thank you much. $5. Much appreciated. Hey, how's it going, Nick? Oh, I don't know, Fred. Hilarious. Okay. Hey, Rumble. Thanks a lot. Appreciate it. It's nice to hear what people think from time to time. Okay. So, like I say, I've got potentially do a behind the scenes mailbag. We could do that. Or if you're not interested in that, we can skip that. That's fine. It's up to you guys. I don't really care. We've also got the HP3561. Yes, 3561. I can't remember the bloody number now. Which we were working on before, and I did the video on previous Friday, not last Friday, one before. I did a video, and that's as far as I've got so far. I haven't touched it in a few weeks, so my memory of what we're up to and what we're supposed to be digging into is a bit foggy. So we'll see how we go with that. But I do have circuit diagrams open already. I had an idea what I wanted to do next. So as a refresher for those people that maybe haven't seen it. Hey Andy, let's go to the top screen. So this circuit diagram section I'm looking at the moment. Remember the error we're getting was that 1100, which comes back to front end control register, which is this block here basically. Right, so it's got signals come through this section onto these registers. It also feeds back out. Then it's got the controls like trigger level controls, and it's got these other controls here, which are AC/DC coupling, BNC1, cal on off, attenuator 40 dB, 0 dB, BNC2, ICP on off, and A weighting on and off, and things like that. Gives you an idea. Alright, so and these are the attenuator controls down here. And DAC controls. So if one of these chips is bad, it could be messing up stuff, but I don't know. I don't know if that's what it is, because the control register error is that it reads back the register and finds out what it's set to. Just check for any discrepancies. So I don't know if we dig that far yet. I think I did buy some chips. I don't know if they've arrived yet. In fact, no. If they have arrived, there could be a problem, because behind me here I have a stack of Element 14 packages. Literally a stack. It's about that long. Loads of packages. I think there's about 15 or 20 packages in there. Could be one of them. But I was planning on doing like a mega mailbag with Element 14 packages. So just Element 14 packages in a big mailbag, just all their stuff. It could just be capacitors. I don't know, but it could be other stuff too. I don't remember. Anyway, so what I'm also looking at here, it gets bigger so you can see it on screen a bit easier, is it has sub-supplies, or sub-rails on this board. So this, actually I'll tell you what it says. This is A10 board, which is the input board. Right, so the very first one it all comes into. Hey Chris. And here are the power rails, which you should be able to find on this board. So if there's an issue with, say, a capacitor or something loading it down, you might find that one of these rails are missing, because it could be loading down because of a resistor like this, for example. You might find that 5 volt there is missing. Something like that could happen. So I want to check all these rails for a start and verify they are at least present. After that, then we have to look a bit deeper. I mean, this is all the relay driver stuff for the attenuators, so we could make sure these are switching maybe, but it involves manually triggering stuff, which is a bit of a pain. So yeah, this is kind of what I'm looking at first, is just power rails first, and then we'll maybe look at this section. But then there's also the next board which I want to look at, which is Digitizer assembly, because they're linked together. They're like signals go across between the two boards, the actual digital signal stuff. So there is some sharing going on. Where's the circuit diagram? So got digital signal control system on here, this board. Test control. Comes with front-end registers and stuff, or front-end latching, so it could be something to do with this chip here. Trying to find something in particular. Maybe it's next page. This also has a whole bunch of sub-rails on it, which need checking. You've got some special ones which are only on this board as well, so you've got like this plus and minus, well, plus 3 and plus 4 volt rails here, which are generated from Zenas, things like that, and also another one just over here. So there's lots of little sub-rails on this one which could potentially be missing if something's wrong. And be very subtle because you only see it on a certain part of the circuit. So checking the main rails wouldn't show up. You've got status latches, which is also what's fed back to the main processor when it's doing the checks. So it reads all this stuff and that's what gets sent back, from what I can understand. This is the ranging stuff down here, these op amps, or comparators, whatever they are. So your input signal comes in, it's amplified. We get the input signal here, which I've actually verified does exist when I'm doing my other testing. That's definitely there. Yeah, a trigger level comparator, which then goes through and other stuff. I haven't followed that. This will display, well, this is for the sensing of the levels. So you've got overload here and here. There's 2 of them, and there's plus 6 dB and minus 6 dB levels. And as you know, there's, what you may have seen, there's indicators on the front panel for those particular indicator functions. So there's an overload which is always on. I've never had that one go off. It's been on the entire time, which means if one of these, probably this one or this one here, are bad, it could cause the overload to be on constantly, which might then give our registers the wrong information and then our feedback. So SStat, that is what's fed back to the processor to tell you what the status of the front end register is. So if that is wrong, it will give that error. So I'm wondering if one of these is the problem as well. Certainly possible. Or even one of these converters over here. I mean, it could be this one here. These are flip-flops, I think. Strangely. Was it? Oh, maybe it wasn't. I can't remember. But anyway, it could also be this parallel serial out register. Could be that playing out. It could be a sub-supply. Could be anything. Anyway. Let's check the chat because I haven't looked at this for a little bit. Yes, Chris is all the gear. Yeah, Christian's only called Christian by his mother, I think, when he's in trouble. I don't know. I guess called his full name. Maybe it's the wife. Maybe the wife does that. Christian. If I get the same thing from my wife, anyway. Won't go there. Hey, Adam. Opening capacitors, yeah, I thought the supply was running out. Well, yes, I bought a bunch of capacitors. In fact, I bought the last of some of their stock inside the capacitors. Stop having stand back on capacitors already. I haven't seen any reefer caps in this thing, actually. I haven't seen any reefers in there. I don't think it's got any reefers in it. Adam, I haven't seen your video. You're always in trouble, Scott. Yeah. It's just the depth that varies, eh? Anyway, so that's what I'm looking at here for this generator. It's trying to at least eliminate some of these bits of circuitry. So if we could test these, I mean, these are just comparators. So all we've got to do is just check the inputs, check the output, and see what we're getting, and that will just verify each one. And that's what I'd like to do, is go through all of those 4 and make sure they're right. At the very least, eliminate those. Now, what you'll see on here, well, you probably can't see it, I can barely see it myself, there's a plus 6.2 volt rail here. And down here is a minus 6.2 volt rail. This is generated on this board as one of these sub-supplies. I think it was on the first page. think it was up here somewhere. Yeah, up here. Here we go. 6.2 volt reference. That's also used here by the ADC here. I think. Whatever it is. Anyway. And there's also got a reference adjustment just here, which is for use of this chip. So plus or minus 6.2 volts are generated here. So I need to also check these exist, because it could even be this. Yes. So yeah, if I had to, I'd put the capacitors. If axials became unavailable, then yes, I'd have to bodge in radials. But I'd rather keep things correct, you know. I don't want to bodge things in and have to use extension wires and all sorts of stuff. Yeah, don't want to go there. Well, sometimes the legs aren't long enough to do a fold around. So sometimes you can, sometimes you can't. License drive, how's it going? Thermal lens cover you sent me, yes you did. ZN SE lens for close-up work. Right. I'm potentially interested, yes. As you know, the thermal camera is a bit of a struggle at close range. You have to sort of hold it a bit of a distance away, and be able to get closer would be nice. So, if that's a practical solution, then I would be interested, yes. I'll have to investigate getting the lenses and stuff, obviously. I'll have to try and, maybe you can tell me where you get them from when you get yours, I don't know. And I'll try and get some as well. Anyway, so yes, we've got a few things we can look at here. We've got this. The main thing I want to do first on this thing is do the references and all the voltage rails on the supplies on the cards themselves. So all the sub rails are verified as being present and correct. Because if there was a fault somewhere, you might find that one of those rails is being dragged down, or even up in some cases. So, right, and CO2 colours work fine. Right. So that's the plan. So are we doing a Mailbag, or are we going straight to the DSA repair or DSA investigation? Hey Peter. Yes. Yes, Pete, you were a bit later. Yeah, but at least you see people saying the same thing. That's always a good thing. Verification. Come on, people, make a choice. I should do a poll. Shouldn't I? Hold on. Hold on. Where's the poll thing gone? Oh, there it is down the bottom. Yeah. Here we go. Make use of polls. Here you go, people. Vote. Vote. Give it a minute, then we'll see what happens. Yeah, the LCD screen, I think it could be slightly better, but I think it's alright. I mean, it's not that bad. I mean, if you think about what was around, 5 years ago, it's It's all better. So I wouldn't worry about it, really. Can't even see my pole. Where's my pole disappeared? Why is it up there? I can't even see the pole. Here we go. I should learn to do this. Oh look, it's neck and neck. So 45% of people want the Mailbag and 10% want DSA. Interesting. Both is 45%. Well, based on that, I'll do both. Because then everybody wins. I think it seems to be stationary now. Right. Maybe there's parts in the Mailbag I need for the HP. Well, that's likely to be the other Mailbag. Oh, look, DSA's come up now. Right, okay. Oh, look, now Mailbag's winning. Oh no, this is not going right. Well, we'll do Mailbag, and then we'll do the DSA, which means you only get both anyway. So this one and this one are the same thing. Should have really thought about that anyway. Right, let's get on with it. What am I forgetting to do? I should have like another camera view there somewhere. Well, we're getting Mailbag, people. Right. What I will do is I'll swap over to my camera. Well, my recording camera. And I'll record Mailbag at the same time. If I plug my HDMI in, then I'll actually be able to see it. Well, that's the plan anyway. Where's my camera? Oh, come on. There we go. It's on a different port for some reason. I don't know why. Decided to be a different port today. Hey Nick. Yep, well, we're going to do both. It's inevitable we're going to do both. Right. So I'll do Mailbag first. It won't take that long. Then we'll get onto it. And play with the DSA. See what we can find. Dig into it. More light. More light. And I'll need to take a picture of this. Enjoying the on-screen display stuff. It's all good. Always need a thumbnail picture. You dizzy yet? Hope no one just fell over. You need a new spectrum analyzer. The oscillator failed. Oh dear. I think you can get replacement ones. Well, you know, on eBay. for a substantial sum. But then you might as well get a modern one, really. If you're going to be doing that kind of cost, you might as well just pay a little bit more and get a more modern one. They have a lot better features than the old ones do. Anyway. It's the mailbag. I still feel like I'm forgetting something. Right, mailbag time. This is what we've got. This looks like it's had a hard life on the way here. Also took a while to get here too. Leave that bit last. Make sure it's focusing right. Hold on. Slightly high. Don't forget to click like and subscribe if it's your first time here. Also, I just passed 20,000 subscribers yesterday. Dave was doing a live stream and mentioned it on there. I was really close and he told me to come and subscribe, and suddenly I got a bunch of subscribers. So if you're new here from Dave, welcome. So yeah, 20,000, finally got there. Took a lot longer than I thought it would, but that's fine. Got there in the end. Next, I think at 25,000 I'll do the giveaway. I was debating doing it at 20,000. So I'll do it at 25,000 instead, because I think that's just a better number. So 25,000 I'll do some kind of giveaway. I'll probably do one to my Patreons and one to just general subscribers as well, so I'll do 2 giveaways basically. That's what I'm planning anyway. Let's see what these are. Lithium batteries, lithium thionyl chloride batteries. Do you know how hard it's been to try and get these bloody things? I've been trying to get batteries. Like I tried to buy them from Element 14, local supplier apparently, but not, because everything's now sent from overseas. So they won't ship them to me because they're dangerous. And then RS components also wouldn't ship them to me because they're dangerous. And yet I can buy them from China. So now I've got loads of these things because I bought a whole bunch of different ones, expecting some to get, told no, you can't have them or whatever, or maybe intercepted or whatever. And now I've got loads of them. So I've got like 10 in here, well 10 here. I've got some other ones I've got before as well, and other mailbags, which you guys may not have seen yet because I'm actually behind in the mailbags. I've got about a month's worth already queued up. Got loads done. Actually having to skip a couple of episodes to try and get things done in a different sequence. Anyway, so yeah, a whole bunch of these lithium cells. So these are backup batteries for like PLCs, stuff like that. And also for test equipment. Test equipment uses them quite a lot. So I'm stocking up because these will sit around for 10, 15, 20 years, absolutely fine. As long as you've still got them in the right storage environment, they'll last years and years. They're long life batteries anyway. So when I do come to use one, I've definitely got something. That's my rant about batteries again. HP3561A 1976. Yeah, it's going to be one big bulky ones, isn't it? That's a shame. Cheap ones using a Yig? No, this use mixing. Modern ones are all digitally mixed and stuff, so you're able to buy one for $29. Wow, that's pretty good. Up to 3 gigahertz. Oh, that's a bit, yeah, it's a bit tricky. I mean, I know there's a Siglent SSA which does 3.2 gigahertz. I actually had to play one once. I never actually got a review done it because it had to be given back because I needed it. So I didn't actually get the review done. I started having a play around with it and familiarise myself with it. But that's as far as I got. I never actually did a review video. because it needed to be given back because I had it for so long because I was busy at the time as well with other things. Yeah. You're from Dave, are you, Sebastian? Good on you. Yeah, Ramstick. Yeah, you always need the right tool for the job. Okay, next thing. Also, thanks to my Patreon supporters and everyone does YouTube memberships. Support helps in the Vikings mailbag, and there's a test script to fix. What's in here? I'm going to read the piece of paper first. Right, okay. Yeah, something else I went overboard with. It's actually sealed. That's a nice level of attention to detail. Oh no, my Ramstick's failing me. I think I need to sharpen it again. Everyone needs a sharp memory. Talk about sharp memory. Here's some RAM. HM4864P-2. Whole bunch of these. So, yeah, I think I went overboard. I never do that, do I? I never get carried away. Because I've got these ones here, then I've got these ones here, and I've got these ones here. I think I need an intervention. Oh, and I've got these ones here as well. So these are RAM which are used in the HP3561A DSA which I've been fixing. So I did need a single chip because I was getting an RAM error when I first got the device, and so I needed one chip, which I've used. I put it in, that actually fixed that particular problem. It's still got other stuff which I'm doing videos on. I think it's up to 6, well, it's up to 5 parts already, but it's going to be at least 6 parts, maybe more depending how it goes. So the RAM is this stuff, and it's got at least 16 of those RAM chips in it. I thought I'll get a bunch and I'll stock up on them in case maybe the ones I'm buying are fakes. You know, so I bought them in different places and that sort of stuff. You're never going to get. There's lots of fake stuff out there. So I bought from different places, and so far all the ones I've purchased have been real. So I've got loads of them. And so, you know, I've got a bunch more here. What's in here? 20 is that? 18 I think? I can't remember. Anyway, I could count them. 5, 9, 18. So 18 there. Plus the ones I've got over here. So I've got loads of them now. I'm never going to run out of this RAM. So, yeah, I've got plenty of that now. Don't talk about RAM problems. Hey, come here, Siglent. Microchips, how's it going? Source of the shortage has been found, it's me. Yeah, that's why I've got so many 1114 packages here. So if you're having trouble finding the HM4864P RAM chips, it's because I bought them all. I didn't buy all of them, I probably bought most of them. Right, next thing. Oh, failed. It's in there somewhere. Here it is. So I bought some of these previously, and then I don't have a use for these. Now these are 3.8mm excellent. I want one of these ones. So I've purchased a bunch of different ones. You can get these little plugs in different sizes, little bungs. suppose you can call them even. So these are 3.8mm, which are perfect for putting inside a 3.5mm jack for headphone jacks and stuff. So if you're trying to make one a bit, dust proof or whatever, because you don't use it very often, then you can get these and chuck them in there. So the link's down below for these things. I featured these previously as well, but I didn't buy enough because I was just trying them out to figure out which size I needed. So I did buy a range of sizes, and 3.8mm seems to be the perfect fit. So that's those ones. And they've also got these other ones. My focus position's a bit wrong. It is, it's slightly out. Okay, there. So also purchase these ones and hope they'll do a certain job too. Let me find the right piece of equipment and I'll see if it actually fits. Where are they? Crap, I have to get a socket. If I remember where to put the sockets, that'd be helpful. Okay. So the intention is to try and get plugs which fit, well, bungs which fit inside this kind of DC jack. It's a 2.1mm jack, because these I've used on some of my projects I've been building in the past, and they're used outdoors, and I want to try and make it more weatherproof by sealing them. So let's see if it's the right size. Oh, it kind of goes in. It's going. Look at that, it works. Excellent. Bit of a tight one though. I might need to look at that. Maybe it needs a slightly different size. That is maybe 0.5 mm smaller, would be better. No, if I do it, that's a 6mm. I wonder if I can get a 5.5. Yeah, it does kind of work though. Right. Chat. Haven't got a load of LEDs. I did buy some of these actually. I did buy some. I don't think it'll be my fault though. I didn't buy that many. It's easy to make custom rubber bungs with 3D printer. Yeah, I don't have any flexible filament. I've never actually tried making stuff that flexible either. I've got a I don't have a direct drive extruder or anything like that. I've got a Boonton tube type, so. Hey, how's it going, embedded hobbyist? Kind of say embedded hobbyist. So that's those. So this one. Oh, I've got to sharpen this thing. This is just ridiculous. This is driving me nuts. Diamond stone. You can't even see what I'm doing, can you? Yeah, marginally better. Definitely too high. Right, try this again. Right. So this is a soldering iron handle and tips, which will hopefully fit on my Jade UD 1200, which I did a review on. This is a C115 handle. It came with 3 tips. I hope this fits. I'll better find out. It's a super fine wire. Wow, it's really fine. Lean over here. Is that the right plug or not? Try and reach around the back of the iron. Ah, can't do it from here. Hold on. Well, it plugged in. That's the first challenge. Let's get some tips out. So what do we get here? TS2115 105, 215 101, and 215 112. So we can see the actual tip profile, shall we? There you go. Let's get closer there. There you go, those are the actual tip profiles. So that's what came with it. Pretty small tips, I mean, there's my finger. Don't pull it. So you've got these little holders, these sitting on there. Pushes in. Should have thought it's supposed to go in. I presume up to that lip there, but it doesn't want to. Let's turn this iron on, see what happens. Nope. Nothing there. I don't think that's right in. This bit here's hot though. Maybe it's not plugged in all the way. Maybe it's a dodgy handle. It's just bent slightly. And slightly pulled out. Let's try the tip. Maybe a dodgy handle. We'll see. Maybe it's something inside which is not quite lined up. It doesn't feel right. It's right. When it's going in, it feels like it's just too tight. Yeah, it's stopping. It's not going right down. How do we get this thing apart? We need to put it apart, I think. Have a look. The bit is spinning. There's a little screw just here, so undo that. Mailbag and tear down. Take it all out. This doesn't seem right. Maybe don't buy this one. Actually, I might turn my iron on without a tip plugged in. Let's see what it does. Don't lose that bit. Yeah, it's recognising nothing plugged in. Okay, so it's looking like it's kind of promising. Just need to get the tip in properly. Wow, this is troubling. It's under here, probably nothing. Yeah, there's nothing under there. It's probably glued together or something. Going to destroy it in an attempt to try and get it apart. Can't be that hard to get apart, surely. I'll come back. It does not want to turn or pull off. Or does it pull off? Anyone know how to get these things apart? Let's have a look. Let's catch up the chat. Just give me guys. Give me a second. Is it right in? No, it's not right in. 8590. Is that the one I've got, 8590? Because I've got one, but that goes up to 1.8 gigahertz. Is that the one I've got? Hold on, now I need to look. What the hell do I own? I don't know what I bloody own. HP. I'm looking through my previous videos to see if I can find it. Um, 8590A is the one I've got. Yeah, I've taken the screw out, so it should come off now, shouldn't it? The screw's here on my desk now, so I've taken it out. It's all the way out. Of course, now I've got bite marks in it from my pliers here. And does that turn? It seems almost like it's glued. Oh, back into doing something. That's coming off. Putting I ripped the wires off trying to get it apart. And I might better find out what actually was wrong with it. Here we go, it's off finally. Wow. There's glued on there as well. Plastic stuck to it, they glued it on as well. So I can get it off. It's broken some of the plastic here. And there's some pins. How does this thing go together? There must be another section just in here. It's not that. Yeah, it's glued there as well, right there. I'm going to destroy this thing into part, aren't I? No, I guess I have to buy another one. There's a separate piece here. There we go. Look, there we go. Right, so I've got the tip off. It's like it's been glued on as well as screwed, which makes it a bit harder. Now I had to slide the sleeve off as well, and it's got a split down here. I think it's also glued. Let's just pull it off. That's the bit we want to get to anyway. So why did that not plug in nicely? So we've got the outer piece. It's the first set of contacts. Let's get closer. So there's the first set of contacts there, which look absolutely fine. Then we've got the second set just here. Let's get some fine tweezers. So we've got the second set just there, which also look absolutely fine. And then we've got the third set here. Also looks fine. Why is it having trouble plugging in? Let's just slide those back together. Got a tip in. Obviously it's not going to go quite as nice. So if that's there, that's fully in like that, alright? And that's where the in was. So yes, it should definitely go right down to that seat there, like I thought. But it wasn't going that far, was it? Maybe these ones here, sorry, maybe these ones here are too bent outwards, so it's pushing too much on the outside, and so it can't actually open up far enough. Maybe it's something to that, because that was really tight. So maybe it's these outer ones here which are causing the problem. They do look very bent, look excessively so. Guess it's going to be gluing this thing back together again once it's finished. I'm going to straighten it very slightly. Okay. Let's put this back together. Like that. So it's not assembled yet, I'll just put it roughly together. I'll just straighten the pins up very slightly. See if this goes in now. It does. Right, now, with it like that, let's turn the soldering on and see if it actually works. Look at that, sunk straight away. My soldering iron's making a funny sound though. As though it's really not liking it. And it's discoloured. It is not liking this. It's almost as though it's shorting out inside or something. This bit here has also got very hot straight away. So something isn't right still. There must be a contact problem inside here. Has it just melted itself shut? I think it has. I don't know. It seems These contacts are all very close together. There's not much of a gap in there. What a crappy handle. Yeah, it went hot very, very fast. I never loosened the set screw and then tried installing the tip. Ah. Does that set screw go through and hold the tip in place? Is that what I did wrong? Damn it. Well, okay. That could be it. I'm an idiot. No, let's go back up there. You guys can't see the chat right now. Let's go back to this. Here we go. You guys all telling me, but I should check the chat again soon, shouldn't I? Maybe Grubsy holds the tip. Yeah. Okay. Yes, I'm an idiot. Okay, I get it. That makes more sense. Right, so it's glued together and the grub screw is to hold the tip in. That does make sense. A question about the Fluke calibrator. I found that Z component open. Okay. 50 ohm resistor. 1%. Well, the percentage accuracy doesn't matter so much. It's more about the temperature accuracy. I mean, obviously, if it's a 50 ohm resistor, you want it to be as close to 50 ohms as possible to give you a correct loading to ensure that it's properly matched and doesn't give you any errors from that result. So if you get a whole bunch of 1% resistors and just select one which has got the closest accuracy to 50 ohms, no harm in that. Oh well. HP3561A, the yellow dial and left open. Find it by it. I think about ordinary replacement. Well, these resistors, these precision resistors, they're usually selected, and they're also usually of great temperature accuracy. So they don't have much of a drift over temperature, or there's a pair. One's a positive coefficient, one's a negative coefficient, so they help cancel each other out. That kind of thing. So those are the things you have to consider. Yeah. I need a beeper for chat. Yes, I do. I need to get Bit Looney to send me one or something. Yeah. Anyway, we'll go back. We'll play with some more. We'll figure out what's going on here because maybe it's not compatible with my iron. I mean, it should be compatible with the iron. I did buy it based on that. But yeah, it looks like it's not good for it. I don't know. In fact, it changed colour so quickly. It's like, it's not good. I'm suspicious this doesn't work. Well, I don't know if a tip went pop or not because I turned the iron off again because I could hear my soldering station was making some sounds like it's struggling, so I turned it off. So maybe it hasn't actually blown. It's just I shut it off in time because I was only doing it for short times. You know. Anyway, let's have a look. Either way, if Even if, I don't know, what else could be there? Maybe I should risk sacrificing one more tip and put another tip in which hasn't been in there yet, with it all assembled fully, and see if that behaves. Maybe it's not compatible with my station. Maybe it's just too much power for it, and it's just blowing them straight away. Maybe it's just crap. Sort of a glow, yeah. Anyway, we'll give it a try. Oh, we want that one. See, what I'm more worried about is blowing up my soldering station. Because there's a good iron, I don't want to blow that up. Alright, so net discarded extremely quickly. I mean, all these terminals are quite close together inside here. I wonder if possibly one of them's touching. Doesn't seem to be, but it could potentially happen. Let's try this one. This one hasn't been powered up yet. If that's pushing that one downwards when I put it in, let's see if I can make that go downwards. Still doesn't touch, so it's probably alright. These aren't great connections on this thing, I have to say, they aren't really nice. Right, let's try one more. It's definitely seated in as well as it's going to get. Right, let's try this tip, see if this one's going to catch fire. That looks wrong, doesn't it? No, doesn't like that. Okay. Don't buy one of these. Oh, guess I'm making an AliExpress claim. Doesn't work properly. Because I don't know what's going on. Is it wired up wrong? Is it not compatible with my station? Although it should be, because I did buy it based off the station. So, it said it was compatible. It's also not right though. Yeah, don't buy it. I'm going to put a link down. We'll leave this one. Now the next thing is to plug my other iron back in and make sure it still works. Might be fixing my soldering station somehow without soldering station. Put it on eBay as untested. Yeah. Okay. Let's turn my iron back on again. Make sure it still works. Yeah, that's fine. Still works. Yay. But it's interesting. But this was heating up straight away and getting hot, right? Oh, mind you, it's not even the sounding station, was it? So that would have been trying to heat up straight away because I thought it was on. Yeah, this is crap. It's just crap. Is it hot? I shall kind of throw it back together though. So, you know, why not? Do it just backwards, don't care. Right, don't buy that, it's rubbish. That tip's probably still alright though. It's probably just not compatible with my station, maybe it's what's wrong. Maybe it's a screw up. I might. Should we test these resistors, see if they're looking alright or not? Let's check these tip resistors and see what we're actually getting here. See if we can determine what's going on. So that's on sounder. We want resistance. .8 ohms. In this end, 0.9 ohms. Between there and there, alright. Between there and there. 1.7 is it? 0.5? It's not very connections, let's try the other one. It's a roll everywhere, isn't it? Right. 5 ohms. That seems a bit better. $10 meg. 13 meg. Yeah, very different, aren't they? I think the tips are just crap. Oh well, let's try those in a minute. Waste the time with these, are we? That one I will look at again later on in case it's right. But yeah. Garbage. Yeah, so don't buy that, it's garbage. That's disappointing because I wanted a fine soldering iron tip for my station so I could do smaller SMD stuff, you know. Because I've got the 245 tip on there. Never mind. Can't do everything. Oh, put these back on. I was going to stab myself next time to get the probes. Right, check chat, then I can do some more recording. Hey Peter, how's it going? Just trying to read the chat really quickly, so I might be missing stuff. So even without me pulling it apart when it worked properly, it was still definitely wrong. Hey Friday House, how's it going? And Drechev, haven't seen you for a little while. Instead you might get the wallet, you get the tricorder, yeah. Okay. Well, that was disappointing. Let's hope this is better. So these are some machine pin IC sockets. I thought I'd get some, because why not? Now, I normally have the press pin type. I've had that. I think they're better in a way, but some people say, you know, these are better because they've got a tighter fit. You know, the fit under the pins a bit tighter because these are round. Obviously, the IC pins are not round; they're flat. So they have to try and deform and bed into the corners of the IC pin. So to me, what you end up here with is 4 points of contact on each pin, which in a way you think that's probably fine, only one really. But if you've got these flat IC sockets, then you're actually getting a contact point across the whole front and the whole back of the pin, if it fits properly. If it doesn't, you might not be getting that at all. So anyway, I thought I'd get some of these. They're cheap. I've got some, just, you know. I only had one of these machine pin ones left, so I thought I'd get some more. But normally I prefer the other type, because to me that type is easier to fit, because the ICs get in and out a bit easier. These are quite resistant to the IC pins going in. You know, you have to push quite hard to get them in, so they're a bit more stress on the circuit you insert in the IC and that sort of stuff. But they do have an advantage, because as you can see, you've got these big standoff pins here, right? So they stand off the board, and that himself could be handy if you've got stuff underneath the component. You can stand it off, or if you've got trouble with traces, you can solder the top of the board, not just the bottom, things like that. So there is a reason for getting these. Don't forget to click like and subscribe if you want to be subscribed, and check out the playlist in the video as well. Now, the squash box. I should pull this out. It's clear. The squash box. Yeah, I hope it's okay. Check. Yeah, some 40 pin ones with 8 pin chips that don't fit. Okay. Does that mean you've got 4 spare pins? So that's not right. I can't even bloody count, can I? 6 spare pins. 10 pin, yeah. Right, well, this package took a while to arrive. Anyway, let's get into it. Shouldn't there be a chat overlay on this thing? It is there, but it's not linked. Why isn't it not linked? It should be linked. Oh, it's hidden. That's why. Here we go. Wonder why I hid that. I'll show it over sideways a little more, maybe. Let's do that. Hey Rob. Audio a bit over the place? Well, it's probably because my voice is over the place, I don't know. But I'm going from different places in the room, so it doesn't help. So if I turn the microphone around a bit, to be a bit straighter, it's pointing towards where I normally sit at the computer, you see. So if I go back over to where the desk is, it should be a bit better. It's slightly directional. Standard yodel delivery. Oh, what's that company? Oh, I forgot what it's called now. Always, it seems that everything I deliver is damaged and broken. Oh, Chris has mentioned it many times. He did a thing about it the other day. Can't remember what it's called now. Anyway, we'll go to this. Right, let's get into here and see what's in this box, and hopefully it's in one piece still. What's a box inside a box? With keeps and newspaper, so very well packaged, Defpom approved. we appear to have a note, so I'm going to slide that out of the way. Don't dock yourself, do we? Right, okay, exactly what I thought it was. We'll shove this over to one side for now. Which I ship just a professional. Programmed. So, this is recommended to me when I was developing this thing here, which is my little DRAM tester, which I built for testing the DRAM on the HP3561 and all these DRAM chips I'm buying. So obviously, I've done projects on this and made it open source. That's available on PCBWay. That's you want to build this yourself, you can. Parts list is there. It's relatively cheap. PCBWay make the boards for you. It's easy, right? And that works for testing 4164s and 4864 DRAM chips, and you can probably reprogram it to do other stuff too. Anyway, this is recommended to me by someone. I can't remember who it was in one of the live chats, and I've seen this on Adrian's Digital Basement, I think it was, and Niall's Retro Lab, I think it was, and so I decided to buy one. Now you may notice it's a bit flat. The components are compacted on this one. Maybe it's because the box is squashed, I don't know. Nah, what it is, it's a kit, you have to build it yourself. So you have to supply your own components. He just sends you the PCB, and you can choose to have the chip programmed or not. And if it's pre-programmed, you don't need a couple of parts, because obviously you had to put those on the boards to allow for programming. So I need to build this project up, and this can test not just RAM, but can test loads of different things. It's mainly meant for retro computer type things, and I think that's the main target audience, was that kind of segment on the market. But it can do so many different things. It can, I think you can program some EEPROMs as well now. It's quite good. So, and it's always continuously developing and adding more to it. So I think there's actually a firmware update since he posted this. There's been at least one firmware update to it. So I have to try and figure out how to program the thing, because it's not really something I do. And circuit programming is not something I've done like that really. Anyway, so that's that. And it's got some messages in here, things I have to read as well. And here is a power supply board which goes on the top here. So I've ordered a bunch of parts, and a lot of them have already arrived. And maybe they've all arrived actually. I've shown them in previous mailbags in the Digi box here, where I've got loads of stuff shoved in here. So this is probably all the stuff I need to work on this thing. There's probably some other stuff I've got laying around which is also for it, but we'll get to. So yeah, I might even do a video on this. I might even say properly. So I might even do a video on this, building it. I may do one. I don't know, how interesting is it watching someone assembling a circuit board? Is that interesting? I don't know, is it? Maybe fast forward like 10 times speed? I don't know. I'm pretty sure I've got all the parts. And I've got the LCD display. I don't know if I've got the ZIF. I think I've got the ZIF. Not sure. Regulators, I've got that chip there. That's somewhere, probably in that box. So I think I've got just about all the bits I need to actually build it. I did order them off the parts list which he publishes for this project, so yeah, it should be there. I don't know, what do you reckon? Tell me down below in the comments if you think that I should do a video assembling and testing this thing and trying it on a few chips. Let me know down there. What do you think? What do you say anyway? It's in 3 languages. Oh, sorry, 2 languages. German and English. Fuses Heathkit 2560 no longer to be set because it's still been programmed. If no picture of us appears during the first run, then readjust the contrast for the trimmer. Yeah, that's right. Normal LCD stuff. And okay, it's a warning about obviously something is encountered with people doing the assembly resistor R57, which is below the MOSFET, which is over here somewhere. It's 58, 57. Smart 4.7. Yes. It says make sure it's 4.7 ohm, not 4.7K. Obviously some people have been confusing it. Because 4.7K is marked 4K7. Yeah, that's fine. It's obviously just a good gotcha which has been catching some people out, so put a note on there about that. And also you've got the power supply board here with a USB-C. Sorry, USB-C. A USB mini. No, not even right, is it? Is that mini? No. It's a USB micro adapter. No, it's not even a bloody adapter. Bloody hell. It's a USB micro connector. I should just give up. Right. That's that. Version 1.2. I think it's got a new version out now. I need to go and check that. Oh, I didn't get it all in. Never mind. So check out the playlist here, there, subscribe link over here, and the Patreon support link over here if you want to help support the channel, help me to buy items from Mailbag and things like that. It's later. Right, that's that recorded. Now we do some real work. That's how long it takes me to record a Mailbag video. Sometimes it's a lot longer than that, actually. Check the chat. Hey Curry, how's it going? What's this? Hold on a second. Let me check something. I'm suspicious. Yeah. That's what I thought. Okay. Reported. In fact, I need to do something. Just give me a second. I'm just going to add this to my blocked information here. Whenever I find a new spam bot, I add the details about that spam bot to my blocked filters so they can't spam again. There we go, added. Now back to what I was doing. Now, you're on that tester too, yeah? Cool. I missed lots of chat. Where was I? I should have paid attention to what the timestamp was. I could find exactly where it was going. Right. No, it wasn't UPS, it's something else. Hermes, was it? I can't remember. I think it's Hermes. Hey RV blog, how's it going? Yeah, it's soldering on tip going red, it's fine. Nothing to see here. But that fault happened and my soldering iron station survived. That's good. So at least it shows that the soldering station was alright. Struggled, you could hear it. Block one spammer, two more take its place. Yeah, well, it's a thing though, you have to just constantly do it. Testing 2114 is a good example of where that could be important, yeah. Did I find if that fixed that PCB for the company? I actually did a second one. Another machine which is a sister machine, it's slightly smaller. Also had a fault and I ended up refurbishing that card as well. Now, there's actually a bit of an interesting update to that in a while as well. Now, when I did that first card, when I showed the Rexroth proportional hydraulic pump control card, proportional hydraulic pump control card, whatever. Anyway, I can't remember what I called it now. But I was doing testing. It looked like tantalums, which are shorted, right? Which was the biggest fault on that card. Turns out they weren't bloody tantalums, because when I got the second card given to me to have a look at, it's exactly the same. But that machine hadn't had a short circuit or fault. It just wasn't working properly. And I thought these are shorted as well. So I looked really closely. It turns out, actually, no, they weren't tantalums. They were EPCOS inductors. So they were yellow like tantalum, had a marking like an arrow to indicate one end or the other, which I thought meant that it was a tantalum. No, it wasn't. It is a bloody inductor. So, so what I actually did was, because I'd given those parts back to the company at the same time, and I refitted those parts back into that card. But that card's not been used, not been put into the machine, because they ended up sourcing a whole new valve assembly, and they just put that on instead in the end, instead of just putting the ball back in. But anyway, but yeah, without the second unit, I ended up getting to check. That's just bad capacitors, same as the other board. The same 4 capacitors, can't remember. I think it's 3 capacitors. They were bad as well, and replaced those, and that's in the machine running now. So that was good. That machine actually had 2 faults. So it had one where it's drifting around, and another one where it's actually a mechanical fault with the pump. So the mechanical fault's been fixed, but the control card was also blowing up. So that seems to have fixed it. So the recapping did definitely improve things. Anyway. Hermes excluded electrical items in their insurance small print. Really? So if they smash up your bits of electronics, tough. Oh, that's yeah. I would never, if I was over there and I had an option, definitely never use them. I've heard nothing but bad stuff. Yeah. You know, I've seen. I just saw a YouTube video. I think it was on YouTube, might be Facebook, can't remember, a little while ago, of a Hermes truck, and the guy was literally getting the packages and throwing them as hard as he could into the back of the truck, bouncing off the back wall. It's like, wow, you know, it's like he's trying to break shit. It's like, wow, how can you run a business like that? How can you have a business that's that bad and still think it's fine? Incredible. Anyway, that's ranting. So that's Mailbag with some interesting things going on there. I should empty my SD card out. Don't know about any memory space. This SD card's been giving a couple of little weird things recently. I'm not sure if there's a problem or not. Could have because I'm getting some power fluctuations. Let me just empty this off, and then we'll do some more. Yeah. I mean, I've had times I've been. It's not happened since I've been in this place, because my mail I've got here is actually really good. The postie I have here is excellent because it's Royal Mail, Royal Post, and even if it's couriered, the same person delivers it, because couriers don't come here, so they drop it off at the post office, the depot, and then my normal postie brings it to me. So my post here has been excellent. I've got a good postie, and I'm really appreciative of that, especially the amount of stuff that I buy, which especially is fragile. So, you know, and it takes a lot of care with stuff as well. So it's really good. He gets a couple of bottles of wine for Christmas kind of thing. You know, we give him a bit of a gift every year to show some appreciation. And so I'm quite lucky. But previously, another place I was at many years ago, before I moved to where I am now, I was at home. I was right there, and there was no knock on the door. There was nothing. There was no noise, but there's a mail card saying there's nobody home. It's like, but I was. And then there's another time, that's happened a couple of times, you know, usual things, if it gets out, I think. Another time I had some stuff which has been, this is a good one, purchased a gel cell, big one, like a deep cycle battery for a motorhome. This thing weighs 30 kilos. It's about 29.8 kilos, something like that. It's just under the limit. The limit was 30 kilos. So it's just under the limit. And the couriers picked it up from the company which is shipping it to me. Like, this is local, within Auckland. So they picked it up. Then they said it was too heavy, and I took it to the depot, which is further away, which we had to go and collect from, because they wouldn't then deliver it, which is actually further away than the place we was buying it from. So we could have just gone to the place we bought it from and picked it up from there. But no, the couriers picked it up, took it to their depot, and then said it was too heavy to deliver. Even though it's below the 30 kilo limit. Well, they picked it up from the place they're delivering from, you know. It's like they picked it up from the supplier. And they took it further away than it started out being. And it wasn't even above the limit. You know, we tried to debate with them and said, no, we just won't deliver it, it's too heavy. It's like, well, it's below your 30 kilo limit. They wouldn't have it. So we ended up having to drive an hour and a half to go and pick this thing up. Yeah, anyway. Order a replacement car battery. Got it by post. Can you get a car battery by post? I mean, surely, I suppose... I mean, if it's a... I even... Lead... If I could string a sentence together, it'd be great, wouldn't it? Lead-acid batteries for cars, they're wet cells. So, wouldn't the battery acid come out if they're tipping the cells around? Or is it like a dry battery, then you add the acid to it? I know you can get those too. I don't have a post box. I used to have a post office box years ago, but I basically never used it, so I got rid of it. The only thing I'd get in there was junk mail. That was it. And it's like, well, I'm paying this much money each year for this bloody mailbox, and all I'm getting is junk mail. I'm paying for people to spam me. It's like, this didn't seem to make sense. Let's sort this camera card out. Let's copied it all over. Now, as I was saying before, this memory card seems to be playing up slightly. I'm not sure yet if it's a problem or not. It might just be because we're getting lots of power flicks and it's maybe upsetting it because the camera doesn't run off a UPS power supply. It's just a cable. You can see this power cable here with a little power supply on it, which came from China. It's not even a real one. So maybe that's on the way out. I don't know. But the camera's not buffered at all, so if there's any little power flicks, it might be upsetting the camera. Not sure yet. Have you had Amazon, the 4-digit security camera you had to give it a moment? Nah. I've purchased stuff from Amazon because I do actually have an affiliate account with Amazon, so I actually have a little Amazon store thing where I put links up for things which people might be interested in. So I'll actually link down below in the description. So if you go to Amazon and buy things through my links, it helps to give me a bit of money so I can buy things from Amazon as well. I don't get cash, I actually just get credit on their system and I can buy things using that credit. And like I bought the Art of Electronics and the X chapters from Amazon using the money that people have basically given me from using my Amazon links, you know, from the commissions. Tanya, normal car battery. Okay, interesting. I would have thought it'd be, you know, a concern about, you know, not being kept upright. Yeah. Some do deliver lead acid cells, yeah. I mean, I've got like gel cells and, you know, sealed batteries, but not wet cells where the, you know, if you turn the battery upside down, all the liquid's going to come out. Oh dear. I used to, I service my own vehicles. Do servicing stuff like that, my own stuff, oil changes and what have you, do all that. Any like mechanical repairs though, like replacing brakes. I mean, I could do it. I have done it in the past, but I just can't be asked. I'll just give it to my garage and say, here, do it. I ain't got time for this. Mind you, servicing's a big saving because instead of paying $150 to get it serviced, that would cost me, I don't know, what, 40 or 50 or something like that. So it's a big saving to do it myself, and it takes half an hour. So I'll do that. I suppose you could say the same thing about doing brakes and stuff like that, but that's not really very common. And I'd rather let them do it. I can't bother getting covered in brake dust and like crap, and let them do it. Anyway, so where are we at to now? Let's just try and reorganise myself because I'm getting messed up here. I've got too many windows open. Haven't dropped many frames, that's good. My wife is currently doing an online meeting. She's doing a Zoom meeting or something. So I'm actually surprised that she's streaming and I'm streaming and it's handling it. I'm actually surprised by that. That's good. It's handling it quite well. I wasn't expecting that. I was expecting to have to drop my bit rates down, stuff like that. Well, I need another drink. And I can't ask my wife one because she's on a meeting. Damn. I can't just message my wife and say, bring me coffee, because it's not going to work. Oh, I should have thought of that. That's bad. Used to build your own car and bike engines. Wow. That's impressive. Okay, so let's play with this DSA. In fact, I think I need to go and get myself a drink of some kind. Go and get myself something. I'll come back because my throat's getting quite dry from talking. Have a beer. It's too early for a beer. It's only 20 to 10. It's a bit early for beer. I don't tend to drink that much anyway, to be honest. I actually had a beer last night. That's the first beer I've had, well, any kind of alcohol I've had for, I don't know, 2 months. I don't tend to drink much. Right, let's focus on the bench and I'll go and grab myself a quick drink and I'll come back. Say no. Right. Wife's in a meeting about. She's on a committee, and I have to do coding potentially for one of our websites. I've got 2 drinks. I've got V, which is not good for you, and I've got one of these, which is marginally better. But this isn't cold. This is. I'm torn now. I want to drink this one, but it's not cold. I'm going to have to drink the V. Anyway, so she's having a meeting, and she told me that she just told me I'm going to have to do some coding on something, which is a massive amount of work. You see with tread marks on it. Really? Tyre treads? Wow. Pretend it's UK time. Anyway, yeah, so. Oh, I'm not looking forward to that. That's going to be fun. That's. Yeah, I can't even explain what they're doing. It's a lot of work. Like I've got time to do it. Okay. because there's some perception by some small number of people in the community that, hey, this could be better. Well, actually, it's been proven it's not going to be. You know, if you look at the numbers and look at the statistics and that sort of stuff, actually they're wrong. But no, it's going through anyway. I need to kind of prop stuff up over here somewhere. And I need to change camera view so you can see what I'm talking about. Right. Now, actually, I want to turn it around this way because I need to work on this side. Plug in. Got stuff half set up here from the last time I was playing with this. So I've got a generator here. I think that's got a kind of riser card. So I'll do the 18 card first. That's just sitting in there. It's actually not plugged right in. It's just sitting there. That's what I was working on last. So pull this out, check the power supply stuff on this card. Then we'll do the same on this card, which I may or may not need to put in a riser, I'm not sure. There's lots of stuff behind this rail we see. Putting in a riser is probably going to be easier. And unfortunately this bloody tab here is cracked, one side's broken. So I was worried about happening with these things. Which riser I need for this one? Yeah, that one there. Okay. Yeah. Okay. Signal generator. Put that in here. I don't need that yet though. I suppose I would if I need to be checking the input levels on those op-amp things, or those comparators, wherever they are. I think they should be on here somewhere. I wonder if they're inside this box. I need to find out where they are. Was it over here somewhere? I can't remember. Check again. Have some more to drink. Got sheet music as underneath the mat. Well, at least I hit it. But having a little, you know, a note shoved in the door saying, "Hey, your package is here," or something would be nice. Having it open in front, yeah. Having it in plain sight, yeah. Well, at least my post is a lot more careful than that. He hides things. It's like dedicated spots. He puts things so we know where to look for them. Used to be able to drink 24/7 in Whitechapel. Yeah. Okay, just trying to drink because I'm definitely very thirsty now. I also got to compose my thoughts, so we need to start with a plan of action. Let's start with a plan of action. Alright, let's do top screen and we'll figure out where we're going to start. So we're going to start on the 18 card, which is the one I've got in the riser. So we have power supplies on the second page, aren't they? Yeah. So I need to check these to start with. Make sure those are in those relevant places. So I'll have to look, say, one of these capacitors on here, maybe, or maybe in that resistor. Both ends of that resistor, minus 15, and both ends of that resistor should be right. Actually, yeah, because that comes in from here, so it's going to be splitting off these two rails. So I need to check both of these points. So I'll check both sides of that resistor. R1, R17, that will give me that one. Same for this one, the positive side, both sides of R510. And then I have to check both sides of R508 and both sides of R408. And then we've got something here, it's like 8 volts, is it? I have to find this one, TP10. Dandelion burdock. Yeah, I tried that years ago, I never liked it. It's about to finish your, it's about to finish your third bottle. No, I'm reading that right. Your first bottle of Togo beer. No PPV3. No, there's no PPV3. I can't even bloody say it. Jesus. There's no PP3V3. Oh man, it's not an easy thing to say. IPA. Right. So, plan of action. We've got to find those resistors and check both sides of those resistors, make sure the voltages are what we expect. And that will eliminate a lot of power rails. And I don't think there's anything else voltage specific on this board. These are all the control lines. I think I've already checked these in a roundabout way, because when I was doing the troubleshooting procedure from inside the manual there, it is looking at these kinds of signals. So I think these signals themselves might be alright. Where's the test points, I wonder? Don't know where they were. Don't remember. Yeah, anyway, so I'm pretty sure signals coming into this section are okay, but I'm not sure. Trying to see if there's any other little discrete supplies hanging around. Right. And on first board here. Current source, no, that works. Already tested for that. Attenuate section, that I don't know. It appears working. Input protection is not shorted because I was getting correct signals. I was doing the troubleshooting procedure and measuring levels in this section. So I think that stuff is basically working. I think I've pretty much eliminated everything on this first section of the diagram already. I think so anyway. Because what I was doing, the diagnostics procedure was matching up pretty much. It's only later in that scheme of things where it doesn't work quite right. So yeah, we'll look at these first. Yeah, it'd be nice to have diagrams like that, wouldn't it? Like the phone guys have got. Going to be back for 10 minutes and you're going to go to a bar and get intoxicated. Okay. Oh dear. Getting drops frames. I've dropped 442 so far since I started the stream. I'm getting a few little flicks actually, so maybe I will drop my stream settings down slightly. It is normal for it to deteriorate as the day goes on. Plus, my wife is live streaming, and she's doing an online meeting, so she's got all these bloody camera feeds going to her computer as well. So, oh look, more spam. Thank you very much, spammer. Go away. Another thing to add to my list. Yes, if you see anyone posting things like that, don't click on them or don't try and figure out what they are, because they go to Trojan sites and all sorts of stuff. Oh dear. Okay, blocked. Hey Danish, how's it going? Andrew, yeah, well the state of players, it doesn't work. Try to install keyloggers, yeah, it wouldn't surprise me. Mind you, keyloggers are probably less effective these days because of the fact that there's lots of people who use password managers, so the password manager inserts stuff into web pages like logins, stuff like that. So I would have thought they would be less affected by that now. Yeah, I don't know. And obviously I still have a place because still going to have to put passwords in somewhere. Alright. That's that gone. Let's get onto this thing and try and find these parts. Do you know what I need? Where is that bloody thing actually? I need my tablet. The little one I did a review on not long ago. It's got diagrams in it. I've got all that. So I can look at it over here by my desk. Where is it? I think it's in the bus. I think it's in the motorhome. Password manager needs to type it at least one time, yeah, but if you've already got an established system there, you don't really have to worry about it so much, but it's still obviously going to be a risk. A friend of mine who admins a lot of websites and does web development stuff, he got hacked. And I'll give you a little story, a little digression before we move on to this, about online safety, right? Now, a lot of people, because of the issues of having so many damn passwords on stuff, if you're not using a password manager, a lot of people will share passwords, like they'll have the same password across multiple websites or something like that, you know, because it's just simpler to remember. Don't do that. Because what happened to this mate of mine, great lesson for everyone, is, let's change the view for a second, whilst I'm berating you for being slack about your security. Someone got into his email, right? So once they got control of his email account, they just went to all his websites and retrieved passwords. Right, so the email account password he had was the same as was used on some websites, and one of those websites, whichever one it is, who knows which one it is because he shared the same password, with some of them at least, one of those passwords got hacked, and then they got into his email account because knew his email was from the web account on the web website it is that got hacked, and then they got his password for his email in his email, and once they got control of his email, they could retrieve passwords from all these different websites, and he basically lost everything. So there are very few things which weren't affected. He lost domain names. He managed to get those back. Access to websites, all sorts of stuff. Yeah, it was a major headache, and it's still not over yet. That was like a few weeks ago that happened, and he's still trying to recover from that. It's been a major disaster for him. So, lesson learned for everyone: don't share passwords across websites. Make sure that each website's got a unique password. Use a password manager if you find it too hard to do it in your head. Yes, I've been owned. Is a good website. That's right, Johnny. Good for posting that. So, I know that some of my passwords have appeared on that website. I do know that that has happened. So, I know things have been leaked. And the thing about having a unique password is that it means if you get that one, it only affects that one website. And then that one's already been hacked. Doesn't matter. So, the main thing is to make sure your email, this is my takeout from this, make sure your email accounts are really locked down. Really complex, long passwords. Don't just worry about having special characters and all sort of crap. Long passwords. Right? The longer they are, the better. So if you can make a 20-character password, that is far better than a 10-character password with special characters in it. Because the length makes it harder to guess. Because the computer doesn't care if it's an A or an exclamation mark. The computer doesn't care, it just tries every character. It doesn't matter. Use password 1234. Oh yes, super secure. No one ever guesses that one. Yeah, anyway. So, listen, learnt there for everyone. Make sure you look after your passwords and especially your email account, because that's how they got hold of this guy's everything, basically. Because once they got into his email, they had everything. Because the email had references in there to other accounts, you know, messages and notifications from websites, stuff like that, and knew which websites to target. And even if they don't know the password to those websites, it doesn't matter, because they just do a retrieve password, goes to your email account, and it resets it, and then they've got control of it. You know, and yeah, it was a major hassle for him. Anyway, enough about internet security. Are you heading off, Kimmy, eh? Yeah. Yeah, it's just something you'll be really careful. If you can use two-factor authentication, well, that's a bit more of a pain. It's not very convenient in most cases. If you use two-factor authentication, that's a lot better, all right? That because if they get the password, they still need your phone or something to put in a code in or whatever, you know, which is harder. Not impossible. They can still clone accounts, but anyway, let's not go there. You let Chrome handle it? Well, Chrome probably does. I don't know, actually. Yeah, I don't know. I mean, browsers will store passwords for you, and they are usually secured. I expect they are, but how secure they actually are, I don't know. I mean, for me, I'm using a Mac, right? So I'm using Safari and Chrome. I use both. I use Safari for most of my stuff and Chrome for basically the YouTube stuff, right? Because it's got some plugins and stuff on extra extensions I can use on it, which are a bit better. And Safari remembers my passwords, but it's using a password manager which is built into it, and it is all secured and tied down, and you have to be logged into iCloud and stuff like that to be able to retrieve the passwords and what have you. So, okay, Andrew, thanks for dropping by, and Johnny, I believe. Yep. Okay, catch you guys later. We haven't started this thing yet. Waffling. It's been going for 2 hours. Haven't started. Oh, this is bad. Okay. We'll go to the bench and we'll start looking through this thing and see what we can sort out. Let's go zoom. I should have used the camera. Let's wake the camera up. Okay. Yeah, so I was thinking I need my bloody tablet for this so I can refer to these manual pages a lot easier having right in front of me. Oh well. It's going to be a bit trickier then, isn't it? So I need to find these parts. We'll start at the top. So we're looking at R508, R408. Now these are in sections. So I think this will be 5 in here. And I can't see component number because it's behind the parts. I need a layout diagram. I'll be right back. I'm going to go get a tablet from the motorhome. I need that. It's going to be a bit easier. My wife's on a break from her meeting, so she's making coffees, which is great. Come on, tablet, turn on. I thought I turned it on. Did I leave it turned on in the bus? Maybe I left it turned on as flat, I don't know. Come on, go, I need you. I think it's flat. Bugger. Ah, damn. Alright, let's plug this thing in charger. There.
I'll shut the door.
Okay. USB-C cable. Alright, yeah, it's turning on now. I can leave it plugged in, that's any problem. It might. Ah, dear. Where did I get the riser cards from? That was from a guy on eBay. There's a guy on eBay which makes riser cards, and he can basically, you can even do custom ones for you if you want. But he has quite a range, and you just do a search for riser card on eBay, and you probably find them. He's got loads. I've bought lots of different ones. I didn't get hacked, no, but a friend of mine did. And yeah, this guy just does loads of them. He's got lots of different ones. I know he will do custom ones for you as well. A certain type or certain size you need, he will make them for you. If you need, I haven't had to do that yet, but yeah, good one, David. Amazon got hacked via Twitch, really? Anyway, so is this thing working now? %, yeah. Look, it's flat. Might have to let it charge up a bit before I can use it. Damn it. Okay. We need power cable. Couldn't find a hole. Might have trouble trying to find a hole. So that's right, I need the layouts. That's what I was going to find, wasn't it? Circuit layouts, so I can find out where these bloody parts are. So what I should do is make notes about which parts I actually want to look at. And then I can not go backwards and forwards between diagrams. So I want R408, isn't it? 508? 508, which is supposed to be 5 volts. 408, which is supposed to be 15 volts. And 17, which is supposed to be minus 15 volts. And then we want, so electrolytic, yes it is, I can probably get to both sides because it's axials. Might be 10 times even. TP10, let's call it TP10, right? And that should be, I think that's 8 volts, I can't quite see. TP10, 8 or 5, can't read it. Okay, so I want board layouts. And let's hope. So it shows the casing on there. So 5s, 4s, and 17. R17 is inside the bloody shielded casing. Of course it is. Alright, so that's, I might take the shielded casing off. That's the minus 15 volt. So 508, 408. 408 is, I'll show you, I'll change view so you can see what I'm talking about. Here we go. So R17 is here, and there's a shielded case. R408 is here. 508 is there. So I get to those easy enough. Now I want TP10. I'm looking for a round dot which says TP10. Can you see TP10? Also got some other test points like 5 volts here. There's one over here as well, and yeah. I see TP10. What's that by? What capacitor was that by? I've forgotten. Is it 418, is it? C414, 418, one of them. Okay. It's 418. And it's C414. Okay. So I'll check either of those. That's also C414. Maybe 418. Okay. So it's the third part up on that side, the edge, and second small resistor up over here. And second capacitor. Oh, TP10's top of the page, was it? There's a minus 15 here, plus 15 here. I don't know, I don't see it. I'll probably blind to it right now. That's fine. I'll measure it in parts, that's fine. Bit of change camera views. And my wife brought me a coffee because she's having a break, so that's great. I've just had a can of V. Never mind. Okay. This cam's probably going to shut off in a second because I haven't touched it for a little while. So we've got 0 volts. Here, give it that. So the ground here, isolated ground. Now if we put the switch here to chassis grounding, not flow to grounding, that way it links them together so it's no longer isolated. I wonder if we should change probes. Now, that's right. Okay. So welcome to the next segment of trying to fix this damn thing. So this DSO, I'm still working on it. It's still giving the error code 1100, which is a front-end control error. So what I'm going to do now is to go around and check power supplies on these two cards. So each card has got its main supply rail comes in, which you already verified for the main power supply. That's definitely working okay. But we've also got, each card's got its own sub rails or filtering built into the cards, that sort of stuff. So you can actually go like through a resistor, and maybe if there's a fault after that point, the resistor will cause a big voltage drop. So that maybe something on the card will be dead, but the main rail will be fine. So you won't be able to detect it. So I'm going to check sub rails on the 18 card first, and then I'm going to also check sub rails on the A15 card as well after that, and just verify that those will at least look okay, because there could be a problem with that. You know, we just don't know. So we need to rule that out as a potential problem. And if there's no power supply problems, then we have to dig a bit deeper and check signal states on transistors and ICs and stuff. But we won't dig it that far unless we need to. So we've got a ground point over here, and we've got some power supply rating. There's a plus 5 volt there. There's also a ground here, cow signal, DAC signal, plus 5 volt here, plus 15 volt here, minus 15 volt right here. So there are some test points around the board for this stuff. But I'm also going to test onto components. So we've got a test on this resistor here, both sides of that. We've got to check on both sides of this resistor over here. We've got to check on these capacitors. I think it's this one here, or this one here. I think it's one of those two. Definitely this one. And just make sure those voltages are correct there. And there's also a test point underneath, well, the resistor, which I want to check is underneath this shield here. So I might have to pull the shield off and check that resistor there. I'm not sure if it's a 5 volt or an 8 volt rail. I'm not quite sure. Couldn't quite read it in the diagram. Could be one or the other. I just want to rule those things out and just make sure that they look right. What's my... see what Siglent scope's set up to do. Give me a second, I just need to figure out what I'm doing here. Doesn't look like my lights are reflecting on it. Makes it hard to see. What I'm looking for, WaveGen. Where the hell's that? WaveGen. Let's see what it's doing. It's doing 1 kHz, 100 millivolts peak to peak output. So that should be alright. Okay. No offset. So WaveGen's putting out something. So it's waiting for a signal doing something. That's obviously one of the things I was using before when I was doing the diagnostics, was to inject a signal and do testing. So this is kind of how I left it set up. So alright, I just want to see what state it was in before I turned it on. Right, let's power this thing up. See what the front panel says before I do anything else. Yep, 1100. That fan is awful. Once I fix this thing, assuming I fix this thing, I'm going to replace that fan. So there's a ground over here. I'll use this ground here. Let's just tap onto there. So this resistor here, 1.8 volts. 1.8 volts. That's not what I was expecting. Was it the grounding I've got? Maybe try this ground over here instead. 1.8 volts. 1.8 volts. That's interesting. That's not what I was expecting there. Okay, let's check this one over here. 2 volts. 6.2 volts. So 0.2 volts. There's a big drop across this resistor as well. Well, that's interesting. R508, I've got it marking as 5 volts. I'm getting 6.2. This isn't going very well, is it? Okay, let's check the basic power rails in. 5 volts, yes. Plus 5 volts, yes. 15 volt, yes. Minus 15 volt, yes. Right, and there's also a capacitor. 5 volts there as well. Yeah, I think it was over here too. This one? It's minus 15. And supply rails stuff here. 5 volts there, yeah. So that's interesting. So I wasn't getting what I was expecting over here. 1.8 volts. Both sides. And 6.2-ish. And basically nothing. That's weird. Wasn't expecting that. I do have the right parts, don't I? R508, yes, definitely. And R408, definitely, yes. Definitely testing the right parts. Tango Cat keeps discounting your comments, does it? Yeah, it can be funny sometimes. Yeah, I'm going to think about changing that fan. I've got fans. I bought fans. I've got a fan to put in there. I just didn't want to put in a $60 fan if I couldn't fix the unit. You know, so I'm just going to wait and see if I can fix it first, then I'll put the fan in. Louder than your neighbours are doing nighttime to this. Yeah, I did check the iGround, and I did check that one against the, is it R48 I checked it against, and it was the same. And the isolated ground is not isolated currently because I did the switch on the front panel which links the isolated ground, or the floating ground, to the chassis. So because it's now linked to the chassis, it's no longer floating, so it should be fine. Yeah, so why is that? Not this one here. So well, you can't see it, it's off the screen. I'll shut this over a bit. If I get the edge so it lines up with what you can see. I don't go outside that space. Right. So R408 is here. That was measuring 1.8 volts. And R508 was at 6.2 this end, and that end is basically nothing. So something is not right there compared to what's on the diagram. Is it sharp on this diagram at all, I wonder? So here's the front panel switch isolation thing here. So they're normally floating, isolated ground and common ground. So when you close that switch, it links them together. So therefore, you get the same thing. That's what I was saying before. Let's get the second page down. So these rails here were referenced to isolated ground. So it's isolated 1, isolated 2. I'm pretty sure it's an 8, not a 9. And that's 408. Was that 406? Could it be 406, not 408? Could that be a 6 instead of an 8? 508 was giving me 6 volts one side, nothing the other. And this shows 5 volts both sides, right? TP11. So we've already got some weird stuff going on. R510. I didn't measure that one, did I? No. That's no one needs to check as R510. Just make a note of that. It should be 15 volts. I don't know, is that for us? Let me look at my physical manual here. I've got my physical manual. Let me check this. Well, if I can find TP11, I couldn't see it on there. I have a physical manual here next to me, which means I can look at the printout of that diagram rather than the scanned version of it, which might be a bit clearer to see. We can do that. That's 509, R509, not R508. And it looks like 406. So it's 509 and 406. That's a bit different. Oh man, I wish I had a better font. So 509 and 406. We'll do this again. Okay. Layouts. Let's find where these are. R509, the second resistor in on this second row, and 406 is the third one down from the top. Right. So 406 is here, and 509 is here. Thanks for dropping by, Adam. Catch you later. I'll see if I can find TP11. I'll have to see if I can notice it. Okay. So those test points I was looking at were not the right ones because the scan isn't very clear. I managed to look on the physical copy of the manual because I do actually have a physical copy, and you can just see from that those weren't 408. It wasn't 408, it's 409, and it wasn't, sorry, 509. So it's not 508, it's 509. It wasn't 408, it's 406. So we need to check those 2 points instead. So I'll turn it back up. So 406 is the third resistor down over here. So third resistor down. That looks like a capacitor to me. Yeah. Oh, yeah. That's C406. Where's R406? Get it right. R406 is over here. There it is there. I'm looking at C's, not R's. Okay, so. I'm really making a mess of this. So, R406 is here. 4.9 volts that side. 4.9 volts that side. That's fine. And R509 is over here. 4.76 volts. And 3.5 volts. Ooh. Is that the right one? Second row. Oh no, I'm looking in the wrong row again. I got this wrong. R509. We call this bit again. Right. R509 is this one over here. So 4.91. 4.91. So that's fine. So now we need to find R510. Which is next to that one. So 510 is this one here. 4.7 volts. 14.9. So it's just bad connections maybe. Let's try and pierce it. 14.7. There we go. So that's got a bit of a drop across that one. So I don't know. 20 millivolts. Is that enough to worry about? Probably not. Nice little 5 volt over here as well. I don't see any markings for TP11. So which one was a bit low? It was at 510, wasn't it? This one here was reading 14.7. That's okay. 406 was okay. 17 don't know yet. TP10 don't know yet. Oh, that was right. So R17's behind the shield, which I don't really want to pull off. chit chat. The fan sounds worse than it actually is because it's only a couple of feet away from the microphone. I've lubricated the fan and it actually made the fan quieter. It was worse than that. Hey, Mako. Yes, no, it is a metal fan. I've lubricated it and it did get a lot quieter, but it's still pretty noisy. For the time being, I'm just putting up with it until I can fix it. Once it's fixed, it'll be different. So that's R510. What's that supplying, I wonder? Because 200 millivolt drop is not much, but why? Haven't found these yet, did I? Was it 41? Hold on, let's see the physical manual. 414 and 413, not 418. I'll check 414, it's fine. R510 is 15 volt rail, isolated supply, and isolated supply 1. Let me see if I can find out where they go to. Let's look at the physical manual first, then I'll come back to the scanned one point out, which is easier. Bear with me for a minute. One goes to trigger level DAC, one goes to a DAC which has got a Zener regulator across it. So we should probably check that as well. R206. Yes. We should check R206 or pin 14 of U202, which is over here. Alright, so let's make this bigger so what I'm talking about. So we've got that one of the supplies which is coming in, which is the one which is dropping down a little bit. Comes in here. So you can see, is it 6.2 volt Zener, is it? It might be 6.2, not 8. 8.2. Could be a 6. I think it's a 6. Wow. Wish I had a bit of font. So yeah, we need to check the voltage here. See what we're getting. So let's measure pin 14 of U202. It'd be easy to find out, wouldn't it? Maybe. Or CR200. That should be easy to find too. Let's measure across that. That'd tell us, wouldn't it? Let's find CR200. Rule that out. Which is over here somewhere. CR200 is right there. Okay. We'll measure that, rule that out. And switch back to this camera. Hey Ray, how's it going? So I'm going to measure across this diode here, which is a Zener. That's loading down the 15 volt rail, which I measured being a bit low before because R510. So I just want to check across that and see what we're getting. 6.2 volts, that seems fine. So that rail should be alright. Is that Zener here as well? 6.2, yes it is. Another one here. 6.2. I don't think it's Zeners, I think it's normal. 14.7 across that one. 15.1 across that one. Okay. Right, back to this. So far it's looking okay. Nothing here to be concerned about. So still need to find this one though, did we? Oh no, we did do that one. Of course, measure the cross that capacitor there. So let's see, we got 506. So we verified those are right. 510, we got that slight voltage drop across here, that side, which is alright. That's I1. I1, not I. What's that one just did? Was that I1? No, that's just I. So I need to find I1, which is the other side that was just there, which has got the biggest drop. So the I output here from this one, which is what we just checked, and that was alright. Yes, I need to check the previous diagram as well. Again, I'm just going to do this on the physical manual. Shall we find I1? Come on, where are you? It's 15 volt one, 15 volt I. There's another one over here, okay. Plus and minus 15 volt, which we're also doing a balanced for the cow signal. Okay, it's probably fine. Where are we? Come on, where is it? Must be on here somewhere. 15 volt I2, which is going to the attenuator. Where's I1? 15 volt I, here we go. Was it I1 I was looking for? Hold on, I lost myself now. What am I looking for? I1, yeah, I'm looking for I1, not I2. Where the hell is it? It must be on one of these diagrams somewhere. Sorry guys, that's exciting whilst I'm trying to find something, but see it somewhere. Need to verify it's okay because it was dropping down slightly. It could be absolutely nothing. But we need to know that for sure. Okay, there's also a pin out. U502 pin 7 is showing us using I1. It's like a chart which lists the voltages where they're going. So U502 again, I'm looking for it. U502 it's part of the cow signal generator. So we'll measure that there, I suppose. Pin 7 of U502. It seems like it's the same place it goes to. Interesting. And the minus 15 volt I1 goes to pin 4. So it's using isolated supply rails for plus and minus 15 volts on U502. So between pin 4 and pin 7. Right. Let's show what I'm talking about. Hopefully. Over here. So here's the chart I was looking at. So I1 comes down to here and I1 here as well. So pin 4 and pin 7 of U502. Seems to be the only device which are actually using it. At least the only ICs that are using it. And there's the IC there in the cal generator. Surprising. So we'll look at that. Have some more coffee. I've got so far as I can at the moment. I mean, it's just telling me I've got a board error somewhere, and I'm just trying to narrow it down because it doesn't make a lot of sense. It looks like it's not quite covering the aspects I'm seeing, so I just want to rule these things out and just make sure that these cards, the sub-supplies in these cards are okay, because if there's an issue with the sub-supply, then it could cause this error I'm getting, which is basically saying that it's not sensing correctly. Also, you've got the front end control error and you've got the 1100 error, and they're related. So I've gone through the test procedure of the 1100 error, and I've basically gone, most of the way through it. I found a point where it doesn't match up anymore, and it just says to test these boards. So that's basically what I'm doing now. Okay, yeah, ARV blog, thanks for dropping by. Okay. What era? I think it was 84, I think it was it? Something like that, I can't remember now. I can't remember what year it was now. I think it was about 84, 86 maybe. Something like that. Anyway. So we'll test on this IC here, U502. Check pin 4 and pin 7, see what we're getting there. Make sure that's not dead. And go from there. Thanks for dropping by, Christian. Catch you later. Have a good sleep. Okay. Back to this. So I want U502, and where the hell is it? Okay. It's one of those. Wow, okay. Which pin's which? Alright. So pin 7 is the... Let's turn it off. We cut? No, here we go. So let's check this device over here, which is U502. This is what the plus 15 volt I1 is feeding. I don't know if it's feeding anything else. It just mentions this one, and it seems to be it from what I can see so far. I haven't found anything else on the diagram. So because we're getting a voltage drop of about 0.2 volts, I just want to make sure that this is okay. I want to make sure we're getting the same kind of thing here. In case, it's maybe that's dead, I don't know, but we'll find out. We'll also roll it out. So power it up. So pin 7 is 15 volts and plus 15 volt, and pin 4 is minus 15 volts. So we'll check to see if we get those. Relative to this ground signal just here. So pin 7, 14.7, it's the same, and pin 4, minus 14.7. Actually, they're balanced. They're balanced, which is good. So that's probably fine. Nothing wrong there. So that's okay. We'll take that off. R17 is at minus 15 volt inside the cage here, which so if we'll find another place to get that from. Terrible fan, yeah, I know. It's just old. It's a really old fan. This has probably had a bit of time on it, I don't know, but yeah, the fan's definitely not really bad. And it was worse than that. I actually got it quieter. So, where are we? Stogame. So what I want to find out now is R17, this one here. I need to measure both sides of that. Now we've got a 512 here, a capacitor on that side, which means we can measure that one. And we've also got a capacitor over here, 202, which means although it's inside the shield, I can probably get to these ones. 202 and 512. If I can measure on those, I will be able to measure that supply rail both sides without problem. So let's find out where they are. So 202, C202, okay, found that one, and C512. Okay, I found that one. Great, I'll get to both of those. Lots of good test gear for noisy fans. Yeah, but you can change a fan. You can just get a fan, just swap it out. You know, you can get some nice quiet ones, which will do similar airflows. So I need to make sure I've got these in my mind properly. So what was I looking for again? C202, C512. C512 is there, and C202 is... I've lost it. There it is. Okay. Let me try and orientate myself on the board as well so I'm getting the right places. That one there and that one there. Okay, figured it out. So although I can't get to R17 like I want to, I can get to other places. Oh dear. Right. So ground on here. So we've got capacitor over here. 14.7 that side. Nothing that side, yep. And over one of these two it was. 14.9. 14.9 there, both probably the same anyway. Yeah, okay, so that seems fine. That's a 15 volt rail, so that's actually what I expected. This one here, minus 14.7. Yeah, it's all fine. Nothing wrong with that. So we don't have a power supply problem on this board that I can see. This board looks fine, at least when it comes to power supplies. So that's that one ruled out, I think. Was that other things I wanted to check on the board? I think it was. You placed the fan, but you can't get it to work. Oh, that's a shame. A664A. What is this A664A? Not familiar with that one. Can a fan start a fire if it stalls? I don't know, maybe. If it's arcing inside, maybe, I don't know. Well, if you think about the cost of those boards, you also have to buy the connectors. And those are, you know, a bit of money themselves. And it's just better to have, say, you know, you're going to get a board which is known to be correct. All you've got to do is solder some pins on, and that's it. And there you go. It's just, yes, it's a bit more expensive than I'd like them to be, those riser cards, but you know, if it means you can fix a piece of gear, it's a small cost. I mean, if I'm recapping a piece of gear, I might spend $200 in capacitors. You know, what's an $80 riser card, really? You know, if I can get a $1,000 piece of gear working for $80 with the cost of a riser card, then you know it's a small cost, isn't it? Really, I just see it as an investment because you don't necessarily only use it for this piece of gear. Like, I've got a range of riser cards now, and there'll be times where I'm sure those riser cards will fit other pieces of gear. So although it's designed for, say, this particular thing, that riser card will likely fit something else another time. So I may not need to buy one that time. You know, so I see them as an investment, really. It's not really a one-off cost if you're getting lots of repairs, maybe. The other thing you could do is you could always use it, repair your piece of gear, and then resell it again. And get some of your money back. Think of it that way. If you don't intend to keep it, or you know, you think you're never going to need it again, just sell it. Not like I'll do that. I'll never sell it. I'll keep hold of it. I'm a bit of a hoarder like that. So I think that's that board there done. I don't think I've got anything else I want to chip on it board, was there? I think that was basically it. I just want to check supplies. So we move on to the next board, I think. Pretty sure. Although this board does have the front end control register, which is where I'm suspicious about things being wrong, you know. But aside from checking those voltages and knowing they look about right, I've got nothing else I can test right now. Unless I'm going to start going around and doing bloody debugging of the bloody interfaces and stuff. I don't want to go there yet. You know, messing with logic analyzers and interpreting the results, maybe. Don't want to go there. So, we'll go to the next board. So this board voltages at least seem okay. I can't really fault anything else yet. I mean, I haven't found anything which looks out of whack. It seems fine. I mean, the voltage across this op amp here, whatever it is, I think it's an op amp, they look balanced. So, you know, it's nothing out of whack. It all looks normal. I can't see anything here which is raising any flags to me. We do have the front end control register on here. So, you know, that's these chips in this area. So if there's a problem with the front end control register, it could still be on this board here. There could still be a problem with this, but I don't know. There's a couple of LED indicators on here, but I haven't found any reference yet to what these LED indicators are supposed to be saying. So whether they're supposed to be on or off, I have no idea. I haven't found reference to those yet. If I find a reference to it, then obviously I'll know what to look for, but at the moment I don't have that. So for now I'm just going to move on, put this card back inside the chassis, and we'll go to the next card over and do the voltages on this one as well and make sure those look right. This has got a few more things going on. It's a bit more complex, this one. So the likelihood of being a fault on this card is actually higher, I think, than this card. But this one's got the front end control register on it. So it could still be here. But it could be the way the data, because it transfers data from this card to this card, and then this one sends it back to the processor. So it could be this card is the problem, which is one, you know, not too fussed about looking at this one. This is an overview and it's checking basics out, then moving on. Because the other testing I've been doing with the diagnostic processes which are in the manual, I've already examined these cards and not found anything. So, yeah, I'm suspicious of this card more than this one. It may not be these, it might even be the A20 card which is behind them. I don't know. Anyway, we're going to get this one out, put this one back inside, and start looking at this one. In you go. I'm worried that sleeve's going to break. Shall I just glue it now and have done with it? Well, it already is broken, it's cracked, but I'm worried about the other side breaking off. I think I should glue that now before I pull it out. Let's find some glue, give me a second. I've made replacements for these before, another bits of gear. I actually have a file on my Tinkercad. Is there anything in there? I actually have a Tinkercad file and Thingiverse file. So it's actually available to download if you need a. It seems to be under pressure. I think it might be blocked. Let's just get a little bit of this. Run it in there. That works. Okay. I think the nozzle must be blocked on it. It's rubbish. Bloody glue. Anyway, yeah. So if you need these levers, you can download it from my Thingiverse and make your own with a 3D printer. Now, what I'm worried about now is gluing that to the board. Let's pull this out without using a tab for now. Let's just take this board right out for a second and work on it. Hold on. I should probably be recording video whilst I'm talking about that lever being available on my page, shouldn't I? Anyway. Make sure there's no glue behind it. I think I've got some glue behind the lever. I don't want to glue the lever down. That would not be what I want to do. Yes, this was split by the pin as well. May have to make a new lever for this one. Anyway, I'm going to keep moving it around so it doesn't glue up in case I did get some behind it, because I think I did. Oh no, it's not exciting. So we've got to figure out where we're going to be testing on this board. So there are some various test points around, some 6.2s over here, stuff like that. Some ground, there's a few ground points around the place. I ground here is a NI ground. System status pin, which is the output, which goes back to the CPU. So this is where the data gets fed back through to the CPU to say the front end control latches are all set and that sort of stuff. Yeah, there's another I ground over here. Yeah, but I've been playing with this thing a bit and I haven't actually found anything wrong yet. I want to do these independent voltage tests, you know, the actual sub-board tests. Oh, I think we're okay. I don't think that's glued down. That's good. I don't know if that glue's going to last or not, but I might have to make a new one. Alright, what size? This one use? Same one? No, use the other one. Right. So we've got to figure out what we're going to be testing on this thing. We want to check those sub voltages. So let's get all this figured out, then we'll come back to this. Yeah, super glue is a bit of a pain, eh? It just goes off. Any moisture in here. It's actually the moisture in here which makes super glue go off. When I first invented super glue, interesting fact for you, its reaction was so fast it would actually explode. So it actually had trouble slowing down the reaction of super glue, so it would go off slower. And what it is, it reacts to the moisture in the air. So if you want super glue to go off faster, make sure it's wetter. So a dry environment will last longer than a moist environment. Okay, so that R17 tick. That's that board done. Next board. Yeah, when I first did all the chemistry and super glue, when I first created it, I found that it was actually explosive. But they had to slow the reaction down. Once I figured out to slow the reaction down, it's alright. But because it's moisture sensitive, moisture was the catalyst. Okay. So we want the next board, which is Digitizer. If you want to, you can also go through this troubleshooting procedure and go through this testing, and I probably will have to come back and revisit this and come back to these stages and go through this whole procedure. Right now I just want to check voltages and make sure they're okay. Right, so it does actually cover a lot of detail in here, things to check and what have you, so that's something I probably will have to come back to. Yeah, I mean, I'm not too worried about the car flapping around, it's alright. Not too worried about it. Right, so you want a second diagram for this card. That's where those voltage rails are. It's also got a 6.2 volt one, I should check that first. So that's U202, pin 7 and pin 1. We'll check that first. U202, pin 7 and pin 1. That's at the top there. We'll do that one first. And that's another one of those metal packages. Yay. When I was doing my plastics materials training, some time ago, I had a chemist doing materials knowledge stuff, right? So teaches about the chemistry of materials, plastics materials, and he used to work for DuPont, and he's a chemist, and he told us all about those issues and things like that. So yes. Let's fire this up. So U202 is here. What did I say I wanted? I forgot which pins I was wanting. This thing isn't fired up yet. Where are we at to now? 25%, let's fire it up. I must have left the tablet turned on and left it in the bus. I was using it. So pin 1 and pin 7. There's also test points. Well, a test point. Oh, there's test points there. Plus or minus 6.2 volts. Yes, so they're up here to see those. So U202 is here. There's a 6.2 there. There's a -5. Where's the other one? Don't know. Can't be too far away, surely. Can't see it. Oh, it's right beneath it. 6.2, -6.2, one above the other. Oh. Bloody hell, I'm going blind. Yeah, I mean, it is wobbling a little bit. It's not going to short anything, it's just going to touch against the casing there like that. It's going to be alright. It's not the best, is it, wobbling around like that? Okay. So let's check this 6.2 volt first, get that out of the way. This is from this U202 device over here. There's a ground point right here, we'll touch onto that. And we'll do the 6.2 there, 6.26, minus 6.2, 6.26, that's good. There's also a 5 volt here, minus 5, yeah, that's fine. So those ones are alright. Teflon. Teflon. Yes, well, amongst other things. Okay. So we know that U202 output is correct, and we can move on from that. Couldn't see that. I didn't change the cameras around. That was stupid of me, wasn't it? Anyway, there's nothing to see. It's fine. I don't think there's anything else on that first page of the diagram we need to look at. At least not yet. No, so we can go back to the main rails on the next page. So what I was measuring, I should point this out, was these ones here, minus 6.2, plus 6.2, and minus 5. And they were fine, as you saw. Maybe. No, you didn't see. Because I'm an idiot. Right. Next page down. Well, a couple of pages down. So these are the supply rails we'll look at over here. There's a few of them. So we'll check all of these, each one, because they all go through a resistor. So if one of these has been loaded down, we need to check them all. Bit tedious, but it's necessary, unfortunately. So we'll check 5I1 on I2. I don't know if I can see them on the layout. Hold on. So minus 5VI, or 5I, which is one of them, but that's not, that's the other section, plus I. Trying to see if I can find them. No, I don't see them. So we have to dig down for these, find where these parts are. So I'll start at the top of the page. So we need to find this 5V2, we'll find that one first, and then we'll find plus 5, which as it's going straight through is probably fine anyway. I don't think that's going to be an issue. If we've got this one, that'll be fine there, so don't check that. Then we'll need to check this one here. If that's fine, we don't need to check this one because it's the other side. So it's got to find this one. And same for these, we'll check these ones down here. We check all these, we don't have to check this one here. Alright, that makes sense, doesn't it? I think so. So I've got to find 5V2, which is AP400B. There's an RP400B. Must be an R. Yeah, it's an R. RP400B, whoever that is. Which would be one of these resistor packs. Try and find it. RP400, there it is. I think, no. There's a U400. There's IP400. So that's pin 3. So I have to check pin 3 there of that device. That's easy. Patrick, eh? That's interesting. Actually, I think my professor actually said that. He might have mentioned that. Actually, mentioned the train exploding. It does sound familiar, actually. Yeah, so if I test up these ends here, it allows for voltage drops from bad capacitors and obviously the circuitry they're supplying. So checking at these ends will be fine. I'll check this one here, obviously that pin 3 of the RP40, and I'll come down these ones and see what we can find. Is there any other RP40 ones here? It'd be funny if there is, it'd be a bit easier. Oh, 400, not 40. Also got this U201 we have to check as well. This is generating an I1, 5E1. We need to check this, U201. And you've got these Zener suppliers down here and here, which you also need to check. So, but we'll start at the top, work our way down the page. So, pin 3, RP40, and then we want to check, and just make note of this so I can come through a bit quicker, instead of backwards and forwards. So, RP40, oh sorry, I keep pointing 40, RP400. 400. So, I want to say it's B. I wonder why it's got a B on it. Why did it be B? Why is it B? I don't know. Pin 3. And that should be 5 volts. But then we've got to check C2 on 1 around there somewhere. Let's have a look for that. Or something like it. C2 on 1, okay, found that. So 2 on 2, is that on the same row? No. C2 on 1, so C2 on 1, and that should be 5 volts as well. And then we've got all these other rails. So 3CO. C307. I wonder if I can measure resistors, because resistors might be easier. 118, 106, 110, 118. What's 118 in there twice? Must be 116. Here we go again. R116, R106, R110, R118. Where are they? If they're all close together, because they might be, it might be easy to measure those. There's R118, R108, R106. It might be easy to capacitors, but the capacitors probably easier to find. C307, C100. C104. Yeah, I have to figure out which one's going to use. HP has individual sections of OS networks. Oh yeah, that could be explaining it there. So B will be a second set, because it's pin 3. Maybe, I don't know. Maybe it goes through 1, 2, 3, 4. Let's go 1, 3. Maybe it's 1, 2, 1, 3, 1, 4, 1, 5. Maybe it's a network like that. Dual network. Could be that kind of array. Dinner time. Hey buddy, I didn't know you're here. Okay. So I need to figure out which ones I'm going to use. I think I'll go for the resistors. I was trying to decide which ones would be easy to find. 104, 110. It's about the same really, so I might as well just go for the capacitors. So C12 we don't need to worry about because it's on that main rail. If the others are okay, you don't have to worry about that one. So C307 we'll look for, which should be 15 volt. Should be 15 volts, shouldn't they? So C307, C100, C104. Cool. Also use the other capacitor. Doesn't really matter. I could use one or the other. C104, C115. Then you've got C401 and C504, and that is 3 volt, 4 volt, and these are all 5 volt, 15 volt. Okay, we'll do this section first. This one's interesting. U304 is also providing a supply. Should I check this too? Looks like it's doing something there. That's why it's noted. So let's do U304. Otherwise I might miss it. Pin 8. Which should be 5 volts. Okay. What I need to do now is pull this page up on my tablet so I can do it over there and be, well, call the layout on the tablet and do it over there, and that'll be a bit easier. Okay. Let's do this. Camera's still on, that's amazing. Hiding in the background, eh? Yeah. Alright. Crates are flying here. Where'd that come from? Door's not going to open. Right. Wait for the boot up. Just need the Office app. So we're in volume 2, aren't we? Volume 2. I'm on the right section. I'm in the troubleshooting section. Actually, I must have been reading that. Come on. Layouts, layouts. Here's the layout. Perfect. Oh, come on, back. Come on. DL. So, 400 is down at the bottom here. I'm pretty sure this is way more. So RP400 is not that, that. Pin 3 of RP400 is over there. Let's test. There's another voltage around here. I've already figured out a list of things, or to start off with at least. There's several sections we've got to go through. It's a bit tedious, but it's necessary. Hold on. I'll do something about this damn fly. Get away. Where'd it go? I want to get a direct hit on it. I can hear it. YouTube stream of someone killing a fly. Yay! Probably go bang now, explode because of all the Fumes. Just notifying me about live streams from yesterday. And Big Clive is streaming as well. I'm sure you guys know that anyway. Where is it? I can hear it. I want to give it direct hit because the kills are quicker. Bear with me, people. Bear with me. Die, you bastard. Hopefully it dies before I do. Right. And I've got the door shut. Right, okay. So, RP400, back to this. Yes, isn't that great? Now, let's do this. Can I get everything in shot at once? Maybe I can? Maybe? Or that? Yeah, there we go. That works on it. Right. Okay, let's get testing. So, that's IP400 right there. Dial resistor array. So ground right here, we'll probe onto that. And we want pin 3. 5.03 volts, that one's fine. Tick. Now we want C. C2 on 1 and stuff like that, so these are up here. So C2 on 1 is just over here, and you can see that on the diagram here, which is there. Stick it on there, C2 on 1, not sure which side I've got to go to. 4.9 volts that side, that should be 0. That's fine. 4.9, so that's fine. Tick. Then we want C307, which is going to be in this area here somewhere. There's R307, C307, where are you? Come on. C307 is right there. Okay. Come on. 14.8 volts. A little bit down, not too bad though. It's going through a resistor, so that's fine. So now we want C100. Which will be up here somewhere. Let me know if you find it. There it is. Okay. C100. 15 volts, that's fine. Now we want C104. Which is over here. That's fine. C115. There's 116. 114. 115. Third one over from behind here, so there. Okay. So that's that one there, is it? Yep. That's fine. They want C401 and C504. Come on, scroll. Ooh, don't go back. Because I want a picture as I'm doing the zooming and stuff, it's being a bit harder. Okay, zoom in more. Oh God, come back. I think I might need a better PDF view on this thing. If you're on a picture, it doesn't like it. So what was I saying I want? C401, which is next to this IC, so it's right there. £4, that's fine. And C504. There is a third part over right there. C504. Come on, get on. Getting 2.7 volts. So that's a little lower than I thought I was going to get. This is Zener. Is it going to that one or not? I can't quite see which one it's going to. It's CR502 or CR501 it goes to. I'm not sure. There's a few Zeners across here. Original 0.3, 0.2, 1.2. I don't know, 2.7. Seems a little bit suspicious. Then we've got U304, which is that one there. Now I need to go to pin 8, which should be 5 volts. So that's pin 8 there. 4.3 volts. Now that is an output from that device. So that may be fine. Let's check the rail going to it. Whichever one that is. So 74, or SN74ALS04AN. Yeah, 4.3 seems a little bit low for an output. Let's just check the other pins. 4.3 on that one as well, and that one. 4.9, which is obviously the input going to the device, VCC pin. 4.3 there as well. So I don't like it's a single line being dragged down, it's like it's just the output. Yeah, this seems to drop 0.7 going through the device. Yeah, same there. So that seems fine then. So nothing too suspicious there. But that 2.7 volts over here looks a little bit lower than I was expecting. Let's look at that a bit more closely, shall we? So it does say 3 volt on there, so that's relative to isolated ground, which I shouldn't have to worry about anyway because I've got it tied. But going to measuring across that Zen, I only measure 1.2 volts. That's curious. So I'll point out on here what I'm talking about. So is this one here I'm looking at, R503. So that one here was alright, that was basically bang on, but this one was off by a bit. That may matter. Fan is dragging the voltage down there. Well, the fan's a 24 volt fan, but it's running on across 2 rails. So it's between a 24 volt rail and a 5 volt rail, something like that. So it's actually only running at about 19 volts. Believe it or not, it's actually running under voltage. Dear. Lots of chat be missing here, haven't I? Okay, right, I think I'm just about caught up. Yeah, exactly. So the voltage being dragged down a little bit, but measuring directly across that diode, it should be a 5 volt, well, sorry, a 3 volt rail. So I should be able to measure across CR400 and get 4 volts, and across CR503 and get 3 volts. So let's find out where those are exactly, and then just recheck both of them, because the 4-volt rail look fine anyway. I just want to do that as verification. And see if I can use that reference point there. Should be able to. Give me a second. I thought so. Someone's just knocked on the door. Give me a minute. Right, so there guys. There's my dad at the door, and I took the opportunity to go for pee while I was at it. Okay, let's quickly grab another drink. I'm still thirsty. While I'm talking. It looks like a beer, but it's not a beer. Okay. Flight's very going now. Flight seems to be dead. So what I've got here is like a tweezer probe, which I can put across that diode actually. So we want CR400 and CR503. And I need to change the camera view so you can see what I'm doing. On it. .503 is the main one I'm worried about, wasn't it? So, come on, peak bigger. Here we go. So CR400 is up here, right there. See what it does. Let's do this before I do much of something around. It's got to get it around. Of course it does. It's measuring 1.2 volts across CR400. That's interesting. And CR502, I'll just do it with this one because I fished this thing out the other day. I haven't used it in ages. So it's doing 0.9. Do it the other way around. 0.6, yeah, okay. This is useless. In circuit at least. So let's remeasure these again. So we've got 400 over here. 50. That's 502. Was it 503 I wanted? That's why. Hold on. 503, I'm measuring one. That's why. Well, this one over here. That's what I want, is it? 503. That one there. So I measure across that diode there, and across this diode here. That should be 4 volts. I'm pretty confident that's fine. We just want to measure this one. So let's measure across these diodes and see what we're actually getting. So this should be the 4 volt diode, so this one should be fine. 4 volts, no problem there at all. And this one here should be the 3 volt diode, getting 2.7 as expected. So the question is, why are we getting 2.7 volts there? So that's going through R501. Now we know what the resistance value is supposed to be for that, so we can work out what the current draw is. So R501, which is right next to it. So we can measure the voltage drop across R501. 12.3 volts. We'll turn that off. Make sure the voltage is gone before I go listens. Yeah. So it's 12.3 volts. You got that? 1.21k. And 1.21k. Who wants to do the math on that? Anyone? Who wants to work out what the current draw is for that resistor? Come on. Ohm's law. But not with the beer, please. Yeah. It's still a bit early for beer. It's only 20 to 12. Oh, it's getting close to midday. It's almost 10.2 milliamps, do you reckon? If I put the right values in myself, it'd probably be helpful. And if I don't screw it up myself, it'd probably be helpful. I get 10.1 milliamps, but then I was using some rounding, so yeah, 10 milliamps. Does that sound obsessive? I don't think it's excessive. Okay, Dave, thanks for dropping by. Ask Alexa. Yeah. So 10 milliamps. What's the power rating of that resistor? What's that? 10 milliamps across that. Come on, more power law stuff. Is 0.012. That's 12 milliamps. 0.0102 times 12.3. It's 125 milliwatts. Yeah, that's not that bad. It's alright. It's half the voltage, half the rating of a resistor. So, is it just that diode's aged, or is it something else going on, you reckon? $10 milliamps isn't much. I reckon that well, that R501 is only a quarter watt resistor. So I'm thinking, let's go back to here and back to layout. See a quarter watt resistor right there. So yeah, it's 10 milliamps. I think that maybe that diode's aged. I think we need to find out what that's supplying. Eh? We'll do that. So what does that supply go to? and then we can rule that out one way or the other, whatever. So that's just 3 volts I, which I have seen around. There's 3 volts, not isolated, that's just 3 volts. That's a plus or minus 6.2 volts, which are used on this overload and input sensing array, which we talked about before. If I've got I3, it's not what I want. There's 3 volt here, but not I. 5 volt. 5 volts there. Where's it go? Come on, where's it go? Don't need to measure the real current, it's fine. Measure the actual resistor value, which was bang on to what the circuit diagram said, which is 1.21k. And we measure the voltage drop across it, therefore we can calculate the actual current draw, or current through that resistor. You don't need to desolder it. Need to find out where this 3 volt I is dropping out. Where is that coming in to play? I need to find that. Is that it there? VI, yes it is. So it's coming into here. So it's on these resistor arrays RP500A, B and C. And it's got an inductor, so it's got a bit of loading across it. I don't know, does that mean it's not triggering these properly? 2.7 volts, is that going to be a bit of an issue for these? Or is it just a biasing? It would just be a biasing, wouldn't it? So, these are these data signal lines coming in. You couldn't keep away. I suppose you got to fall asleep with the laptop in bed again. Just make sure you don't block the air vents up, otherwise you'll be killing your laptop. Make it. I'm not sure we want to go there. Okay. It's a weird setup. Having a data course says that's CR501, 502, 500. That's interesting. Obviously, this is the isolation barrier, right, between the digital circuitry and this board. So this is adding a bias onto these inductors. Obviously, when you've got signals coming in this side, it will be changing the voltage coming out of these relative to what's coming in, right? Because it's obviously going to affect that. It's just a bias circuit, so it probably doesn't matter. It could be fine. But then what's loading that down? I mean, there's no other connections here. There's nothing to load it down, it's just floating. Unless it's getting coupling in from this side, which will be pulling it down. Oh, maybe. No, I think it's probably alright. I mean, it's 10% down, which is a little bit concerning, but because these are inductors, it could be some coupling back through from this side, from these being in an off state, which would then cause a current flow to drag it down slightly. It might be nothing. It might depend on what this stuff is all doing as to what you get on this line. Yeah. And the 4 volt one was perfect though, wasn't it? And the 4 volt was 4 volts on this side, and that's perfect. VI, there's an isolated 4 volt rail, and that was bang on. So that'd be a similar circumstance, wouldn't it? I wonder if I should replace that Zener with a new one. Do over 3 volt Zener. We've got a 3.3 volt Zener. I don't really have anything that low. No, I've only got 3.3 volt. It's the lowest I've got. I don't think I've got. I don't know what I've got in surface mount stuff. I wonder if I've got a surface mount Zener which will work. I do have a 3 volt surface mount Zener. In my little kit here. So I do have a 3 volt Zener, but in surface mount package like a MILF package. It's a bit of a bodge, isn't it? What to do? I'm definitely inclined to lift one end of that Zener and insert one of the surface mount ones. It's a bit of a bodge to fucking wire in, but yeah, I think I'm going to have to do that just to rule that out. Because if the voltage comes up and I've got a bad Zener, if it doesn't come up, then it's probably fine. Or it's being loaded a bit. So we'll go with that first. We'll give this a try. Which bit have I got this on? Yes. Probably right. So what I'm going to do now is just check. It's beeped. Something's beeped. What I'm going to do now is check this Zener here. What I'm going to do is lift that Zener out because it's measuring 2.7 volts across it. It could be nothing. It could be the Zener's getting a bit weak. It could be a bit loading on the circuitry. It could be completely normal. But I don't know yet. So what I'm going to do is lift that Zener out. And the only Zeners I've got to replace it with, which are 3 volts, are these little surface mount ones. There's a MILF type fitment. So I'm going to have to bodge this in somehow. But it's only to test it. So I'm going to lift one end of the Zener out, tack in one of these, and see if it changes anything. And if I get the same result, it's probably normal. If I get a change, if I get 3 volts instead, then I can be confident then that Zener there is, deteriorated and isn't quite as good as it should be anymore, and I can then look at replacing that. I won't use these long term. I'd use a proper through hole Zener, but I don't know. I've only Zeners I've got a 3.3 volt, which is, I don't know if it matters or not. It may not do, but I might be able to go 3.3 volt. But I'd rather use the right part if I can. So I'm just have to bodge this and see what happens. And I need to change camera so you guys see what I'm talking about. Could be coming from the diodes themselves, blocking the other direction. Yeah, maybe. Let's measure a parallel 3.3 volt with a 30 volt. I don't think it quite works like that. Yeah, so we're going to do this. Look at the clock pin of J30. Yeah, I mean, I could look at those. I mean, those are things I need to check anyway. But I'm just suspicious that... yeah, anyway. let's go to this. Yeah, right, let's lift this out and we'll go from there. We'll probably do it without lifting out the circuit actually. No, let's let the board out. Must be easier than trying to wobble it around. And it's a folded over leg, of course it is. So I'll try and get this oh god, I can't string a sentence together. I've got to try and get this desoldered. But it's got a bent over leg, of course. So I need to try and straighten that up. What I really want to do is lift it out. There we go, it's straightened up. So I'll heat it up from this side and just lift it out. I'm going to use my angled ones for this. So I'll get underneath it. Okay, this is then lifted out. Now flip it back over and bodge in one of these ones. I'm going to need a bit of wire or something to bridge it across. I'm sure I've got something laying on my desk here amongst all my rubbish. Anyway. This is going to be fun. Right. So let's solder onto that side there. With the banded end. And let's get a piece of wire. I've got a few bits laying around on my desk here. Just find something suitable. Just trying to tin the wire, get it ready. Okay, it's way too long. Come on, attach. Okay, that should be done. And of course, if this diode is not conducting properly, what will happen, instead of being 3 volts going through the circuit, it'll be something much higher than that. So I've got to be really careful that it's definitely got a connection. Because what rail was that running from? That was from what supply rail? Five volt rail, so it could potentially run 5 volts through if that diode isn't conducting. It probably wouldn't be a problem really, to be honest. Not for a short time. So, let's just organise myself here. Obviously, I'm not going to be measuring here. I'm going to be measuring on the pad down here. To make sure it was in voltage mode. Okay, ground. Pad. Getting 3.3 volts. That's not 3 volts, is it? But it's come up. We're still getting the same error on display, so it hasn't changed anything. So that isn't a 3 volt, that's a 3.3 volt. But it did change, so I'm obviously suspecting now that this Zener here is a bit dodgy. Actually, now it's out of circuit. Let's test it with this. Actually, no, which side's positive with this thing. I think that's the positive. The top one. I don't trust this thing. It's 1.9 volts that way. Let's try it this way. 0.7. But no time does that say the correct voltage. Yeah, I don't know. It's supposed to measure Zeners. I'm sure I did actually use it for this. I just seen it on draw for ages. No, I don't know. Let's just put it back over there and pretend it doesn't exist. So, changing that Zener did change the voltage. I mean, is 10% high better than 10% low? Oh dear. Checking the clock pin, yeah, well, I will look at that because that will obviously tell us whether or not the devices are correctly flipping around and getting signals. But I'm just suspicious that voltage isn't what it's supposed to be, and also it may not be an obvious fault, but it may be something which is going to start playing up. You guys are cheating on me, are you? Going to see John. That's fine. If you want to go watch John, that's fine. Go watch John. Yeah, Zeners are definitely, they're not accurate. They're not like they're oh, what's the name for them? It's gone out the top of my head. It's gone off my head. It's going to come to me, I'm sure. There's a name for them. I forgot what it's called now. Where you get diodes which are actually much more precise than the Zeners. Can't think what it's called. No, not dynamic resistance. It's got a name for the way it folds over to the voltage. It actually locks onto the voltage. The I can't think of it. It's completely gone. I can't think of what it's called. It's another kind of diode. No, it's not the. So it's another diode. I can't think what it's called. It's completely gone out of my head. So Zener diodes are a little bit soft, but there's another type which is a much harder response. They're used for clamping stuff. Damn it, I can't think of what it's called. Anyway. Never mind, if it comes to me, I'll tell you. It's on the tip of my tongue. I'll just Avalanche. Yes, Avalanche. Avalanche diodes, yes, that's the one. Good one. Yeah. So I don't do anything until I get to that point, and then they suddenly just kick in. With Zena's a bit more linear. They when they get close to the voltage, they start to activate. With Avalanche diodes a bit harsher. They basically get to the voltage, then they suddenly trigger. Right. I think that Zeno should be replaced. I don't trust it. It could be a factory modification. I decided later on to change it to a 2.7. I wonder if I can read any markings of it. Maybe it's actually a 2.7 volt diode. Just bear with me while I try and look at it. Because if it is actually a 2.7 volt diode, then it will be fine. I'll leave the thing alone. And unfortunately my microscope is out of action because it's got stuff piled on top of it. I have to use my nerdy magnifier hat. Right. Markings are multi-rotor device, just like 020 945 425. That's what it looks like. Any ideas? 020 945 425. Um, 925 425. Is that what I said? 00 020 95. See if anything comes up. None of these look right yet. Element 14 match came up as a 3 volt diode as a different part number. Sometimes there's a clue what's going on there. But there's a whole bunch of other stuff which is shown up as well, which is completely wrong. Anyone find it? Well, I've got this other Zeno in there which is doing 3.3 volts and it still didn't boot, so that isn't causing the boot failure, or that error message I'm getting, so it's not that as the direct cause, but I'm suspicious that this isn't right. So I just want to make sure that this is what it's meant to be. Where's the parts list? I might have to look at the parts list. It's tedious trying to find stuff in the parts list though. I could do a search, see if it pops up in the search. So it's CR503 on the A15 assembly. CR503. Hopefully it will find it. No, didn't find it. So I can't find it. Can't search the document. I'm going to have to do this the hard way. It's in here somewhere. So we want, it's at page 53 there. It must be 100 or something, wasn't it? Must be around here somewhere. Okay, where's the pass list? See here somewhere. Right, let's do it this way. Come on, where is it? Is it in the other part of the manual? Let's have a look. Where's the other part of the manual? Okay, found the other part of the manual. Right. It's in this one instead. Which board is this one? Oh, this is going to be tedious, isn't it? Let's see if this one's got a search in it. No. Oh, yay. This is going to be fun. If anyone wants to find it before I do, please do. This might be change notes or something as well. It's also possible. I don't actually know. I'm just looking for CRs and see if I find something which looks about right. What's that? No, this is that one. It might be change notes. Oh, where the hell is the index? Let's find it this way. Index. Where is it? I can't find anything today. Replaceable parts list. Table 4.3 is in section 4.5. So yes, it is in the first manual. Section 4.5, which is kind of where I am. This is 4.3. Alright, well I must be in kind of the right place. Really? These are updates. Those are updates. Okay, 4.3. Just look around the middle somewhere. Here we go. Here's another set. What board are we on? A10, wasn't it? A15. A15. Was it 899? I hate trying to find parts. A20, A15. Here we go. We're close. CR 503. There we go. There's the codes. 1902. That's right. 1902 0945. It's a HP part number code, which is a 3 volt. Yep. It's a 3 volt diode. It's supposed to be 3 volts. So this is what I was looking at here. CR503 1902. So we saw 020945. That bit there, the code matches. So obviously it's the 19 at the beginning is missing, which is their designation obviously for diodes, I'm guessing. But yeah, Xenon 3 volt 5%. So yeah, it's 5% out from what it should be, because it's giving a 10% error. 4 watt. I need to replace that diode. I need to get some. I should leave a service mount voltage across it. Only a 3 volt, not a 3.3 volt. It's marked as 3 volts, and there's obviously 3.3 volt ones. Or there's not enough loading across it. Yeah. Yeah, I need to get the right diodes. That's annoying. So yeah, I think I need to replace that just because it is out of tolerance. I mean, this part is definitely matching, so it's definitely supposed to be a 3 volt diode, and it's not. Yeah, 3 volt 5%. Well, 5% is only 2.85 volts, not 2.7 volts. Because 2.7 is 10% of 3 volts, isn't it? So therefore, you know, because you get 0.3 volts drop, so therefore 2.7 is 10 volt is 10%. That's what I'm interpreting anyway. I don't know, Fred, why are you looking at it as 5% as that? I'm not sure. You're also looking at it differently from what I am. That's my interpretation. You know, 2.7 is 10% down from 3 volts. Which would be out of spec. Well, does it even matter? I mean, I don't bloody know. It probably doesn't even matter. I don't want to go 10% high from 10% low, because that's not really much of an improvement, is it? Okay, I think I should make a note of that and saying I need to replace that diode. Because if I just replace it, then we know for sure it's all good. Yeah, I'll get the right diode and I'll replace that. But, so we found something which isn't quite right, but I don't think it's the cause of what's going on. So we'll keep on looking. Let me show us down here on volume 2. So we're on, what page were we on? 53, was it? Roundabouts there? Yeah, okay. So we verified all this lot. apart from obviously this one here. Need to check these ones here. So next we need C57 is probably fine. That'll be a main rail coming in. Not to worry about that one. We've got another 3.9 volt. So we've got another 4 volt rail and another 3 volt rail there. Okay, so that's C505, which is 4 volt, and C404 should be 3 volts. These are not isolated rails. Surprised they came from a 12 volt. Yeah, I'm surprised they came from a 12 volt rail though. They came from a 5 volt rail for those ones anyway. And then we've got U201. -5 SI. We've measured that one already. That was the one that was at the top of the board there. So that's fine. We don't have to do that one. We've already verified that one. Okay, Andy, let's drop them away. Come on, where's the rest? Zoom out. Where's it gone? Let's lose this bit. Right, so we want C305. These should be -15 volt. C101, C110, and C210. Okay, we can check all those ones. Let's go through this list. See if these are looking different. Well, better be 10% low than 10% high. Yeah, potentially. But these are acting as a bias on those inductors. So either way, I mean it's a 5 volt circuit, so it can go up to 5 volts and be perfectly safe. But it's a biasing, so that may matter. It's obviously meant to be floating around the center point or so. I don't know, is 2.7 going to be fine? It may be because it's close to the center point. So you go plus and minus from that. So, I don't know. I'm going to remove the 3.3 volt bulge. Yes, I will do. Because once I replace that diode, I've got to take it anyway, so I'm just going to put the other one back in again. And we'll work through this list. And let's go back over. Oh, it's gone all dark. Yeah, suck that hole out. It's not something new every day, is it? There's the bodge. Maybe just to warm up a bit more, it's a bit slow. mean, that diode I put in was supposed to be a 3 volt, but it's obviously not. I think I might mark that. This is some I got from China in a kit. So they mislabeled them, obviously. Some quality for you. Right. Let's put this away before I forget and get it out of the way. Should have flow through, I expect. Yeah, it's fine. Trace on the top anyway. Alright. I'll stab myself with tweezers, that's always fun. Not. And wait to wake this back up. Come on, wake up. Right. Stayed on this time. Must have been enough random readings to keep going. So now to do some more testing. I've replaced this diode, put it back in. Well, I've inserted the diode that was already there, which is measuring 2.7 volts, which is too low. It is a 3 volt diode, so I'm going to get a new diode. I'm going to replace that, but right now I don't have the right parts, so the smallest I've got is 3.3 volts in that package style, so not suitable. I need to get the right part for that. So for now I'm just going to keep on going with what's in there. So now I need to go through the rest of the list and see what else we can check for. So I need U304, sorry, no, we don't know, we've done that one. C505 and C404, 4 volt and 3 volt rails. So define those. So C505 is there, and C404 is where? C404, where are you? I'm C403. And 406, it must be there somewhere. That's a mystery. Anyway, we'll check this other one. I'll have to find this other one. C404. I think I've got it right. Might have to double check that. So we'll check this other one first, get that one ruled out. C505, we'll find that one first. So 505 is over here. 3.9 volts, and it's supposed to be a 3.9 volt Zener in that place, so 3.9 volts is fine, that's okay. Although it says 4 volts, it says 3.9 Zener. I'm going to find this other one here, C404. Who is that? There it is, it's over here. Okay. Oh, and my meter just turned off. .9 volts, there we go, that's fine. C305. That's there. Okay, so C305 is just there, I think. I think that's it. Yep. Minus 15, yep, that's fine. That's good. Now I want C101, C110 and C210. Slide this down a bit. So C101, C110. Just got to find them first. C110 is next to the IC. Keep getting these swapped over somehow. Not that it matters that much, but I want to try and get the right readings. C110 is next to the IC, so that's that one there. -15, that's good. C101 is somewhere up here next to the other IC, just there. Which one is it? -15, yeah, that's fine. And C210 which is somewhere. C210, it's there, that one there. -14.7, yeah, that's alright. Okay, what else check out? Yeah, I'll check that clock pin. Once I find it again. No, what? I do want to check the clocks anyway, so there's no harm in doing that right now. Once I figure out where it is. So U500 on pin 12, and there's also a second clock here, I think. Yeah, it's 10.24 here as well. So it's got 20.48 and 10.24. So I should measure on pin 4 and pin 12 and get those two signals. Let's get the scope set up. U500, I need to find what that is as well. Scope is already here, I just need to actually use it. And you can't see what I'm doing, just haven't changed the screens over because I'm an idiot. You might be able to see the scope. Not with this view, unless I show you the scope instead, I don't know. Maybe I could do that. Let's wait the scope up. So U500 is that one there, I think. That's 501, that's T500, that's not right. U500, there we go, over there. Oh, come on, Leech, you bugger. There's no ground over here, it's fine, I'll use this one. So what pins did I say I wanted? Forgotten. 4 and 12. I should probably show the scope, shouldn't I? Oh, not one. Set up. Okay. Let's quickly check it before I do a test. 12 would be that one. Maybe. Looks like it. So when I get this set up, then I'll show on the scope screen. Now, I hope if I actually trigger off the right bloody input as well, that'd be really great. Source, because I've got on channel 2 instead of channel 1. Yeah, it's nice and noisy. Let's get a bit of trigger. Okay. Right, I'll show you guys in a second. Yeah, maybe I get both in shot, that'd be good. Which one do I want to focus? The circuit board or the scope? Which one? Right, let's test on U500 for the 10.24 MHz and the 20.48 MHz signals. So 20.48 is on pin 12, which is here, and that's there. As you see, it's got a positive offset. What are we on? 1 volt per division, so it's about 4 volts there, almost. Pretty close to it. About 3.5 volts peaked. And we want pin 4 for the 10.24 MHz, which is very similar, also looking fine. So that's alright, that's like 3.5 volts there. I'd like to see a little bit higher, but it's okay. Maybe it'd be slightly better with that different Zener in there, because it'll give it a bit more of a bias. So it's probably, no, maybe it should be about 4 volts with that other Zener in there. So yeah, it's kind of working. I mind just on the outputs on that device. We should look at the inputs as well, see what they say to you on the inputs of it. So the input pins are pin 1 and, no, sorry, pin 3 and 13. So look at the inputs, see what's going on there. So look at pin 13 first. That's what's going in. And pin 3 is that one there. Yeah, I mean, it looks okay. Yes, you know, it's a waveform and it's consistent. It's repeatable. Not jittering everywhere. That one looks nicer. A lot of ring in there, but part of that could be my leads and stuff here, you know, the way I'm probing. But it is running from a inductor, so yeah, it's okay. It's going negative. Not sure about the negative aspect of that. That's like 0.5 volt negative ringing, and that's almost nothing there, negative ringing. So yes, I think it does need that Zener changing, because I think it is causing a negative offset when it should be more positive than that. Yeah, it's an interesting number, isn't it? Pin 3, J300, pin 3 is easy to get to. It's the signature analyzer connector. Okay, where is the signature analyzer connector? I don't know. Where is it? I actually have a signature analyzer. I do have one. Where is the signature analyzer connector? I don't know where that is. You better educate me, so I'm lost there. Oh, there it is. Right. Oh, okay, I got it. Deft Edge. Right, found it. It's in the 300 section, obviously. So that might be related to one of these, though. I mean, it might be in there. So where are you finding that information about the J300? Obviously, it's referenced in it somewhere. I've just not seen it. Let's go with that. Get these artifacts and do this. I'm obviously missing something that you've seen. There it is. Down there. So clock signal here is also here. Okay, yeah, right. So we could check that as well. No reason we can't check that. Well, in case it's different. I mean, it might be somewhere else. Maybe a break or something else is going on there. So that's coming from that clock line, which comes across from over here, which comes from straight from there. Okay, yeah, right. Okay. So yeah, I've already checked that one. You're right. Yeah, I do actually have a signature analyzer. It's out in my other lab, in a drawer. I've never actually used it, but I've got one. I'm thinking because it does actually have signature analysis. Can I say signature analysis on this unit? It does have the signature codes and stuff for it. So that is something I probably will be looking at some point, but it's a bit of a pain plugging it all in. Anyway, it's something I'll probably end up having to do. Right, so voltages look good. You now own an 8594E. Congratulations. What's an 8594? Is that like the high frequency? That's my E must be quite a newer one. It might be quite a fairly recent one. So what's that? Is that going to be 5 gigahertz or 8 gigahertz or something like that? Is it? I don't know. Yeah, I might end up having to use signature analysis on this thing. I mean, so I bought one, so that when I did need to do that, I'd have the tool to do it. I think I showed it. I probably had it a couple of years, actually. I've owned it a couple of years. I don't think I've done anything with it. I think it was powered up and worked, and I don't think I actually did any work on it. 2.9 gigahertz, okay. Yeah. So I was next going to look at the don't know the reference. It was the signals in here we were going to look at next, weren't we? We were going to look at these next because we're getting overrange on the display constantly. So I wanted to check these U2 inputs and outputs and the U300 inputs and outputs and make sure they made sense. Does that make sense? And that leaves rules out because I think some of my repairs are probably a bulk proportion of my repairs have been capacitor related, so bad caps, right, causing ripple on the supplies and or bad tantalums or whatever, right? Capacitors, most common failure. Second most common is probably op amps. Third most common is flip flops. Alright, so that's the sequence I go through: is capacitors, op amps, flip flops, because those are what I've been seeing as the most common failures in the top three. So when I see an op amp, I'm thinking, okay, it could be that. If I see a flip flop, I think it could be that. I mean, like previously in the last video I did, and I think it did the last stream. I think we were looking at the flip flops. Right, reason being because I've seen them fail multiple times. Now they're a failure point which I'm always suspicious of. That's why I was looking at those, and it seemed to make sense for checking that particular part of the circuit at the time. So now I'll look at these With op amps or comparators, I mean, they're pretty much the same thing. So I'm suspicious of both. So we'll look at these next and just rule these out. So U2 and U300 we need to look at and check the inputs and the outputs to make sure that the signal coming out matches what should be coming in, or vice versa. Now this is interesting because I've always got overload on display. Now this actually has two outputs connected together. So if you look at U300B here, you've got overload here as a test point. We follow that up, it comes back into this one. And this one here is also an overload. A bit confusing because I don't want to have two signals going from the same point. Anyway, so it could either be this one here is giving a signal, which is let's see, we'll split these out. So I had the signal comes in here through the amplifier. I'll come from the bottom here, right? Signal comes in from the A10 board. It's got some limiting in here, obviously protection circuitry, just to clamp it, so if it goes above 0.6 volts or whatever, it will clamp it down. Whatever those might be, I think they're 0.6, I don't know. Depends what they are, might be, not Zeners, are they? Standardised, so 0.6 volts is be clamped to. Amplified 4 times, comes up here. I'll ignore this other stuff over there for now. Let's look at this bit. So it comes in here, then it's comparing that input signal against a minus 6.2 volt rail, or a proportion of that, because don't forget this is a, well, as you can see, maybe it's a diode ladder. There's a diode in between each one, so each one steps up. So that's this one here be the low level, because it's got 6 dB minus, and we've got 6 dB plus up here. There's a ground reference here, so these are negative values, these are more positive values. So this will be underload, and this will be overload. Yeah, I don't know. Anyway, I don't actually know what these devices are. I should look them up and find out what they are. But there must be open collector or something, because having two connected together on the output, that must be open collector, surely. It does have a pull-up resistor here, which makes me think also open collector outputs. So we want to check this one first as an underload, and then I'm not seeing these LEDs coming on, so these ones are probably okay. I mean, these are signals come out and get converted and stuff, and to the waveform serial data goes back to the main processor. So these haven't come up. Either this one or this one is. So I think I might just check them all anyway, just to be sure. But yeah, this is why I wanted to check that 6.2 volt rail as well, because this is a reference that's used by these devices. Right, minus 6.2, plus 6.2, split rail. So yeah. So anyway, as I was saying, the signal comes in here, compared against the negative rail here, or proportional negative rail. Actually, that might be overload, that might be underload. Think about it this way, actually. That's the higher level there, isn't it? So it's a high voltage in there. So that must be, if that's higher than that, oh bloody, I'm confusing myself now. If this signal here is more positive than this signal here, that will be on. But don't you want it to be off because it's got to pull up? Anyway, we'll see what the signals are. It'll make sense in the end. Yeah. Oh look, more spam. Fuck off, spammer. Anyway, right, so let's get this thing hooked back up again properly. I need to hook up the generator again, so I can control the levels, and we'll do testing of the levels and then we can actually make sure that these are switching like they should be with that level changing. That seems to make sense, doesn't it? If they're changing levels, and we should measure them as they are, then change the levels, see if they're switching, and at least verify they switch. We could do that too. LM319N, you reckon? U2 and U300. My tablet's gone back to sleep again. That's annoying. Come on, wake up. U2 is a 1826-175. I think it's a 5. It's in shadow, might be a 6. Pretty sure it's a 5. And U300 is the same device. Yep, 175. So that could be looked up quite easily and found out what it is. So there's test points here for these as well. So there's overload, test point, and 6 dB plus and minus. So that's all there in that area. So I want to measure. I'll do the top one first, So it's U2 first. I want to make this bigger so I can see it, and then I'll change camera views. The output is feeding inverted S input at U305. Yes, it is. So inverter here, this one here, yeah, that one there. Also got this inverter here, which is from these 6 dB. So I've also got these latches here, which we need to look at. I just want to do it stage by stage, so we can go through, check these comparator snap op amps, wherever they are, and if those check out okay, then we go to the next stage and just work our way through, because there can't be much to this. I mean, it's detecting that the front end is not right, and how it's doing that I'm not entirely sure, but it's got something to do with this data here. This thing here has got something to do with it, right? Because it feeds back data from this parallel thing. So it could be something as simple as one of these are latched and it's stuck on, and it's therefore it's giving a misreading, and therefore it doesn't know what it's doing. It just goes to some kind of fail-safe state. Right? It could be something as simple as that. It could be one of these comparators are dead, and that's it. So that's what we go through from here. Logical process, working the way through, and now I've eliminated power supplies as being a potential fault. You always want to make sure power supplies are right. Now I can look at this section and make sure these are behaving as they should, and go through the logic state of it instead. Open collector. Yep, cool, I was right. Excellent, thank you very much. LM319s. I've actually got some of those too. I've actually got some LM319s. Got some around here somewhere. So, that's good. I've run out of drinks again. So I'll do U2 first, then we'll do U300. Just because, top to bottom down the page. So I need to make this bigger so I can see it, because I'm using layouts on now tablet. So 8, 10 and 7. Right, so measure those 3 pins, see what we get. Has that chap been covering up the multimeter the whole time? Just noticed that. I've been a bit slack in my configuration here, but what you guys can see. I've been messing this up the entire time. So what was it again? Oh, my shoulder's getting sore. 8 and 10, then we'll check what pin 7 is doing. So, well, 10 and 8, then pin 7 of U2. So, what were these things? These are 14 pin devices. So now we're going to move on and measure these devices here, which I believe to be LM319N open collector op amps. So I just want to measure the pins on these, the inputs and the outputs, to verify that they are all doing what they're supposed to be doing, in case one of them's stuck on or something like that, because they do fail. I've come across them numerous times. It's one of my high suspicion points is op amps and comparators, because they do fail. So you want pin 10, so that's down there, that's low. Pin 8 is low. Pin 7 is high. That's been pulled up, so the output is currently turned off because it's got pull-up resistance in the outputs. So that is not active. So 10 is 0.008, and that's nothing there. So pin 10 is higher than pin 8, so that should be off. That is correct. Let's check the next pins down, which is a different device. Well, same device but different function. I just want to check the whole device. Pin 4, well 5, 4 and then 12. So do the same thing. 5, 4 and 12. So pin 5. Oh, I want to do the negative side first, don't I? I just want to keep myself logical. Yeah, 5 is the negative side. So pin 5. 0.08. Pin 4 is higher. So this one should be on. And the output is pin 12. So this should be low. And pin 12. It's high. Do this again. Pin 4 is 0.64. Pin 5 is 0.07. So therefore, the output should be on. And it's high. So I'm getting different results here. Am I reading this wrong? Am I misinterpreting something here? So pin 4 is higher than that one, which means the output, pin 12, that's high. That's the opposite of what the first section was doing, which I just measured, which was pin 8, which is low, and pin 10, which is higher than pin 8. It's the opposite way around, and that output was off, wasn't it? Yeah, so I've got two different states, both got the same output. Okay, now I'm confusing myself. That doesn't seem right. Because it's got open collector, that makes it a bit more interesting. Might have to look at the dial sheet for this device. Okay, let's look at the next one. We'll see what the next one says. So that's U300 we want to look at next. Hey Nick. Progress? No, not really. Found one Zenodide, which is a bit off value, but that's about it so far. So I just want to check the other side. Alright. More bloody spammers. So, U300, we want to check. I'm just going to work down again. Pin 10. That is 8, not 9, isn't it? Let me double check this. Is it just me interpreting a number wrong again? Change pages in my physical manual. I can't tell. Maybe it's a 9. I can't tell. I'll have to look at the data sheet. Hold on. Pop a data sheet for that device. You reckon it's an NM319, eh? So let's look at that. NM319, I must have it here somewhere. Comparator, yep. Okay. Comparator. 8 is a ground. 9, I was thinking the wrong pin. It's supposed to be pin 9. Right. Okay. So the dodgy print in the, or the dodgy scan strikes again. It isn't pin 8 it's supposed to be looking at, it's supposed to be pin 9. I knew something wasn't right. Okay, so let's go back and look at pin 9 again. There we go, that's high. And that's like, there we go, now we've got the same conditions. So that actually makes more sense, right? So that is, pin 8 is high, sorry, pin 9 is high, pin 10 is low. Right. Makes more sense now. Now they're both doing the same state. And desktop screen. There's a data sheet I was trying to show. Oh, you're trying to show. So there you go. So yes, pin 9 is high. That's so that has a high state, as does that one. Okay. So we did the same thing on this one. So I measure the same pins on this device, exactly the same configuration. So you want pin 9, not 8. That's 0.64. Pin 10, and then pin 7. It's 0.3. That's an interesting voltage. Measure again. 0.6. Nothing. So that's not being pulled up with, what is it? 0.3 volts. That might be worth investigating. And the other ones were 4 and 5. So there's pin 4. There's pin 5. Pin 5 is lower. It's minus. Why do I have a negative voltage going in there? Oh, that's right, because it's got a negative pull. That's right. Okay. So let me just check the rails. That's ground on this one. Is ground. What's the positive pin on this thing? Just want to check the rails going to it. So we've got grounds. We've got 2 grounds. Interesting. Okay, so it's got 2 grounds going to those devices, and a V plus and V minus, which are on pin 6 and pin 11. Right. Pin 6 and pin 11, let's check those. So it's 6 minus 15 volts, and pin 11 is that one. Plus 15 volts. It's plus and minus 15 volts, that's correct. So we've got grounds, which are obviously references for these. That's like a central point. Yes, so it's a center point reference. And the other one is on pin 3. It's also ground, that's fine. Okay, so there's 0 points. And plus and minus. So it's got 3 power supplies going to it basically. Well, 2 power supplies. Right. So what I was saying, so pin 4 is 0.02. Pin 5 is minus 1.78. Which is meaning that should be in an on state. So pin 12 should be on. It is. And let's get back to 9 and 10 again. 9, 10 and 7. Let's recheck those. Make sure I'm half confused myself. 9, 10 and 7. So 9 is a negative state. 10 is 0. So that should be on. So pin 7 should be a low state. Which is that go to the right point. Ground point. Ground point. Here we go. Yes, it is a low state. That's why it's 0.3. Okay, that is actually working. Right, so that shows that those comparators are working correctly. The outputs match what they should be. Right, so those appear good. Rolls those out. There's the next bit to look at. Yay! What the hell is this thing? U305. Reset, set. Not set, not set, really. I can have 2 set bars. What the hell's a U305? It's obviously got 4 segments to it. Or 3 segments at least. Yeah. What's U305? And my tablet's gone to sleep again. I need to change this timeout on this thing. U305 is okay. So I've ruled out the 2 comparators up here. Right, so those are working fine. At least they seem to be. I didn't end up injecting any signals in, but the states are in right now are correct. Didn't seem to be faulty, so and it was in its running condition. Those won't be causing problems, I don't believe. I could also inject signals and check the states to make sure that they switch if I want to be really thorough, but at the moment they look like they're right. I don't know. I'm actually wondering if I should go back actually and do that and inject the signal to make sure there's definitely switching going on there, in case they're not switching states. I've got that doubt in my mind now. I need to check that. Let's plug this in. I need to do this. I think if I don't investigate that last little potential thing, I need to. It's going to be playing on my mind about is that right or not. So we inject a signal here from my scope. Well, when I say from my scope, I mean because it's got an arbitrary waveframe generator built into it. What voltage comes up to in this thing? Max 40 volts peak. Alright, so heaps of headway there, that's fine. Okay. So let's check. Oh, which ones was it I wanted? forgotten which pins it was. Anyway, which section it was. 1.8 there. Nothing there. Let's change this output. Let's do 5 volt. It's the top section. I wanted this one. Not see anything changing there. What can I see? Can't see a magic smoke from there. Oh, that's right. So let's. I need to check this. I just got this here in my mind. I was going to move on to those, but now I'm thinking I just want to input a signal into these and make sure these actually switch. I might need to do some manual stuff on here to actually change the attenuator settings. Comp in, I should be able to measure something here, alright, and then I should be able to make sure this is triggering these. So I need to measure this comp in until I get a signal here, and then we'll go from there. Back to here. I'll get set up, then I'll start recording video. Comp in is where trigger conf DRQ 0H, come on, where is it? Comp in, there it is. Right. So that's 0.08 right now. Measure it again, so that's changed. It's the same. I think I might need to do something different here. It's the same. Not seeing a signal level change. That's going to be AC, isn't it? Because I'm inputting my signal. Comp in. 0.03. I don't think it's a DC level, it's an AC level, isn't it? Same. I don't actually remember what this is doing. There we go, got something different there. That's in putting 6 volts peak to peak and getting 0.09 instead. So it's starting to come through now. Yeah. Okay. I'm losing my focus. Check it for times for amplifier. Well, that's kind of what I'm doing now. Here we go. So comp in is what I was just measuring at just here. And once I was, when I got to points, was it 6 volt peak to peak in on the B and C, then I was starting to see something here. U301 is a high bandwidth. Okay. Yeah, because when I was doing the actual debugging process on this thing, well, debugging the diagnostics process going through the manual, I did measure this stuff and it was looking okay. Because it does, you have to go through menus and do certain trigger states and stuff like that. I think I showed it in the videos, I'm not sure. You go through a diagnostics process and you go to menus and you control the attenuators and stuff like that, and actually free touch deck, wrong window. What are you talking about free touch deck about? And I did remember seeing the correct signals at this point in that particular process of the steps. You had to adjust attenuators and you could actually see what was going on at this point. I remember that being correct. So I don't think this has got a problem because I've kind of already ruled that out. But up to that point, I tested up to that point, but I couldn't test these individually. So, but I do want to trigger these to make sure they switch. Diagnostics process. Can I follow the process here quickly? Is there a thing I can see here to do this? I was trying to find it. It's ADC stuff, it's not what I want. ADC timing control is not what I want. I might have to go digging. No, I might have to go digging through the original part. Let's see if I can find that. Yeah. I do want to just have these switching to rule them out completely. Because right now, yes, in the current state they're correct. But are they wrong in a different state? I mean, I know the overload's not turned on. Or is it? Because I'm getting an overload signal the whole entire time, right? Regardless of input level, so what I think I need to do is play with input levels and attenuator settings and monitor this overload signal here and see if that turns off. Because if this turns off here, but it doesn't turn off on the front panel, then I know that it's not interpreting the data. But if this never turns off, I know there must be something wrong with one of these. Not switching when it should be. Not turning on when it should do. So that's negative side. So this is a pull up from 5 volts through this resistor. Give it a bias. Does it? I don't know. 1K there, so the voltage divider came through there. Oh, come on, which one's underload, which one's overload? That's the high side, so that one must be the overload, this one must be underload. Surely. Because that's compared to the lowest voltage, and that's compared to the highest voltage. And that's compared to the higher voltage, and that's compared to low voltage. So yeah, that one there must be overload, and this one here must be underload. Okay. Just trying to click my thoughts on this. I need to find the process which allows you to control this comp or comparator input level here. I need to find this again, and find that, then I can control that level, and then we can see what's going on with these. That's what I need to do. I need to rule this out completely. So there's no, was it or wasn't it that? Have I missed something kind of thing going on? Was that 250, was it? It's around here somewhere. Zero code descriptions. Where's the thing which tells me how to fix it? Come on. I don't know where it was. It might have been the start of manual 2 actually. Might have been start of manual 2. Down a bit. No, here's a test sequence. Right. Let's test G. We'll try and find the right place. Yeah, here we go. There might be test G as well I need. Hold on. That might be the right page. I just need to check. SA20 board. Yeah, okay. I think test G is what I need. Yeah, okay, test G is what I want. So this is the process I've actually gone through so far. Here we go, component in. Right, so this is the bits I'm seeing. I was seeing this stuff being correct. Pretty sure size being correct. So, but I want to re-trigger this. So I need to go through this process here and just make sure. I'm pretty sure this bit was right. So this is the bit which was bad, alright? So this is a bit I've got point to. I'm string a sentence together. So this bit here. So connecting it up 50 ohm 3 which I do have here. I will have to hook it up. Do all this stuff, 1 volt IMS. So I can input that, that's fine. Define the range as 0 volt dB, 0 dB volts, so it's a second attenuator. And it's input trigger, stuff like that, and percent of range, so it's 50%. And then set the markers up. Then it should appear as per 6.22, which is this. It does not, because I've got nothing on screen. So this is a complete fail, right? Don't get that at all. Then it says the front panel over LED should be off. Well, over LED is always on. Right, so it comes over here, it says this fail, inject this stuff in. So we're checking these output signals and trigger levels, stuff like that. Now I've done this, and they were right. So that wasn't a failure. Then it says to continue to the next bit. So, you know, it's yeah, I mean, the complexity of these things is quite staggering, really. There's a lot to them. But if you think about it in blocks, right, each block just does a certain function and they just merge them together, I suppose. But, you know, there's probably one team on each section of it or something. And they say, right, this is what the inputs and outputs must be, make that happen. And that's it. Probably, I don't know. So I need to go through this process here again and set it all up as per this and confirm those are working or not. So I think I'm actually going to kill the stream because I need a break. I'm losing the plot a little bit, I'm losing my focus, so I need to go and have a rest and just recoup myself. And was it a DC offset? There's only, I was measuring, was it 0.03, was it? I think it was. Very small offset. I think that's what I saw there. Yeah. So, yeah, I think that's what I need to do is go through this, verify for sure that these are definitely switching like they should be by driving different levels in to try and trigger them. If these are all triggering correctly, then at least I know that's definitely eliminated, and I can move on to the next section here, which is these latches. And after that point, there's not that much left to go on, really, I suppose. I mean, it could even be the same wrong with this part here, the U405, or maybe one of these voltages here are bad. I mean, we checked those already, but that's a isolator. I mean, inverter could be dodgy. Who knows? It could be this serial register is bad. But I just want to go through in a sequence and go through now each input and just rule them out and just say, right, those are definitely good. I can ignore those, move on to the next section, and eventually by process of elimination we're going to find out what it is. So, thanks Anonymous for dropping me away. You can go to bed now. So yeah, we'll call it a day for the stream, I think. It's been interesting. We did find something. We did find that Zener die, which wasn't quite right. I'm going to have to get some of those and do something with that, and we'll carry on. DC level, yeah, I'll check that. I'll go back to it. I'm going to revisit that section, just go through that again and just see what comes up. But yeah, something is... no idea. Oh dear. I mean, that's... It does have some capacitor smoothing on here, some maybe more high frequency filtering on it. So I was expecting an AC ish. But I don't know, is it AC or DC coming through here? I don't know. It must be DC, but then it's got these back-to-back diodes, so maybe not. You can't see what I'm pointing at. These here. If you've got back-to-back diodes, that would usually signify an AC signal coming in. Or at least a positive, negative signal coming in. Yeah. Anyway, right. We'll call it a day. I need to go to a rest and have some lunch or something. And thanks to everyone dropping by. Give us a thumbs up for relief. And yeah, got 20,000 subscribers now. Excellent. Thank you very much. Surprise. So anyway, there'll be more videos on this. I'm obviously going to compile a video out of this footage we've recorded today and get that done. And it might be this week or the week after. I'm not quite sure how I'm going for time and what I've got to actually do. Yeah, we'll see how we go. I'd like to have an ending to a video to some kind. So some kind of, I don't know, structure. Yeah. Okay, thanks for dropping by. And I'll catch you later.